Good afternoon, everyone. I hope you and your family members are safe and healthy. Thank you for joining us for today's webinar. My name is Pooja Sutar. I am the Marketing Executive at Sarla Advantech and I am the host for today's session. We will just wait a couple of minutes because I am seeing few attendees joining in. So we will just wait a couple of minutes. Okay, so today we are presenting the webinar Kepware Discovery Day 2021. Just a little housekeeping before we get started. If you come across any questions during the session, then please type those questions in the question section available on the panel on your right hand side. We will try to answer them at the end of the session. Let's start with our webinar. So I will ask our speakers to introduce themselves. Steve.
Hello, everyone. I'm Steve. I'm actually the senior application engineer with Kepware. If you have attended the seminar last year, so I'm the same guy who's speaking today.
Thank you so much, Steve. Then we have Mr. Suresh Kumar from Mind Infotech. Suresh, I think you are on a mute.
Yeah, good day all. I am from Motherson Sumi Infotech and Design Company. We are from the Motherson Group of Company. I am representing here for my experiences with Kepware and share some of the experience with you guys all. Thank you.
Yes, thank you. Then we have Shinu Zakaria.
Hello, good afternoon everyone. I am Shinu Zakaria and I am from the business development team looking after the Kepware business in India at Sarla.
Thank you, Shinu. Then we have Nilesh Jangle.
Good afternoon, everyone. I'm Nilesh Jangle, and I'm working with Sarla Advantech Pvt Limited from last 14 years, and I'm currently working with pre-sales team here in Sarla Advantech.
And we have Priyank Patel.
Good afternoon, everyone. And this is Priyank Patel from Sarla Advantech. I'm hosting like a project engineer, working as a project engineer in Sarla.
Yes, thank you, everyone. During this webinar, we will be covering these topics. We will have a brief introduction of Sarla and our partnership with Kepware. Then we will go through KEPServerEx latest release updates and ThingWorx Kepware Edge. Then we will have this Kepware experience. We will just listen a few words from Mr. Suresh. Then we will go through some major drivers and plugins from Kepware, and then we will have Kepware Link Master and Redundancy Master. After end of this session, we will have a Q&A session. So now, without any further delay, let's start today's webinar. Shinu, all over to you.
Yeah. Good afternoon, everyone. I hope you can see my screen.
Yes.
Yeah. Thanks, everyone, for attending the Kepware Discovery Day webinar. Since we are all associated in some way with each other, I will not take much of your time and quickly run through this a summary of what we are into and our association with Kepware, so that we can go straight into the webinar. So, Sarla Advantech, we are a proud team of over 450 people, and we are committed to delivering the best solutions in the automation software, manufacturing and MES space. And we have been in this space for over 20 years now, delivering solutions across various manufacturing industries like pharma, chemical, metal, energy, automotive, etc. So with around 15 plus offices across the globe, we have completed over 2,500 plus projects. We are now, we were previously associated with Pidilite Industries earlier, but now from around 3 years back, we are part of the ATS Global Group, who are again independent solution providers for smart digital transformation for users worldwide. We at Sarla, we had a long-standing partnership with leading solution providers like GE Digital, offering various automation softwares like iFix, Simplicity, Scada, Historian, WebSpace, etc. SAP, MI and MES, Verum for the MES services, OPC router, and of course Kepware. Kepware, as you all know, is a PTC company. Was founded in 1995 and released the industry-leading KEPServerEx, as you all know it, in 1997. Steve, who's joined us from Kepware, will give you a short summary in his next presentation. So we have been associated with Kepware from year 2012, close to 10 years now. We have a dedicated team of 30 plus engineers who have supported 400 plus businesses with innovative and robust solutions. We, with this partnership, we have had a long-lasting association with many of our SIs and OEM like you, who has joined us today. And we have also been able to complete many projects and gain trusted relationship with many major end users in India. So that's from me. So I think Steve will continue from here. Yeah,
yes. Thank you, Shinu. So we will move to our next topics. Steve will be guiding us through.
Hello. Can you guys see my screen?
Yes.
Yes, Steve.
Hello and welcome to the India webinar. I'm Steve again. I just do a brief introduction of myself. So I'm the application engineer based in Singapore. At any point of time, if you have any questions, feel free to type it into the chat box, and I think someone from Sarla's team will be helping me with that. So just a brief introduction of Kepware before I go into the product updates. So for those who are not familiar with Kepware or new to this webinar, Kepware is actually a company that has been around since 1995. We are located in Portland, Maine, so it's a US-based company, and we have over 20 years of development on driver connectivity. And in fact, for the past, the entire core business of us, we are just focusing on driver development, right? So whenever you buy a Kepware product or driver, they come with that many years of driver enhancements and quality, right? So back in I think 2016, somewhere along there, we were actually acquired by PTC, which is a IoT company. So now that's why when sometimes when you hear about Kepware, you will see the branding to be TTC rather than Kepware. So we have been acquired. However, within the greater company, we are still fairly independent as of now. The typical industries that we service are factories, work sites, cities, and offices. So these are some of the key industries that we package our products and look into in terms of product management and industries that we focus on, right? So for factories, for example, we are focused on things like the PLC drivers, your automation stuff, CNC drivers, IMMs and things like that. So some of the two of the drivers that we use in that kind of environment will be discussed later on, the Euromap 63 and the MT Connect. The next industry that we have, work sites. So that's where we have specific drivers such as the flow computers and things like that. And on cities, we have mainly on the building automation side, so BACnet, Modbus and things like that. And for offices, we have specific IT-specific drivers such as the SNMP, which allows you to connect to manage switches or even UPS and any of these managed devices. So these are some of the examples that we have. And if you look at the map on the bottom left corner, so one of the important things to note with Kepware is that out of the US, we operate exclusively through our distributors. So every single country will have one single distributor. So for India, it will be ATS or Sarla, right? ATS Sarla, which will be our distributor or preferred distributor in India, right? So our partners such as ATS, which is the reason why I'm here today, because we work closely together and they are actually our tier 1 support, right? So if there are any issues, any queries, reach out to ATS Sarla and they will be able to help you, right? And on the right side is just some of the accolades that we have. So just some of the awards that we gain in terms of recognition of our product, right? So most of our customers who have used Kepware, they are fairly happy with it. They things that they say such as it's easy to use, you can quickly connect to the devices that you want and move along. And things like the software itself is stable, right? Because of certain technical features that we have. Right, so what does Kepware really do is that if you look at what our platform or rather our software provides, what we're really doing is that we bridge the OT side, which is on the all the different field assets that you have, PLCs, some of the brands that I've put in this picture over here, and we can connect to these devices and we are able to get the data out and pull it into Kepware. So once we put it in, we can actually then bridge it out to the consumers, right? The consumers could be a typical Scada application like, GE, iFix, Wonderware, your DCS, for example, OSI Pi and things like that. So those are the consumers, right? And then we also have the, the more IT-centric products such as Splunk, or even the cloud solutions that we see nowadays. So really this is what the core feature or core thing that we do in Kepware. So we move data from one point, the data sources, into the data consumer. We facilitate that in a very reliable architecture. Right. So for those who are also in industry 4, this is connectivity is identified as one of the key layers or key things that you probably should look at, to go into before you go into industry 4. It enables you to develop that capability, because before you do any of those I4 stuff, you need to have data, right? You need to be able to connect with. Okay, next on Kepware, right? Because one of the things that a lot of customers appreciate from Kepware is that for Kepware, we maintain our product, right, as a continuous improvement method, right? So every quarter we release a new patch. That patch contains like bug fixes or even security enhancements and things like that. So you can see from a screenshot, right, you can actually download all the different versions of the Kepware on mykepware.com, and you can actually read out on the changelog on the right side. Right. So just look for it under our website. You can see this.
Sorry to interrupt you, but your voice is slightly breaking. So can you please check that?
Oh, is it? Can you hear me? Is it better? Hello, hello.
Yes, we can hear you, but it's slightly.
Okay. I will try to speak louder. Okay. And I'll speak softer. slower. So these are some of the examples of the releases that we have. And you can see on the right side is the change log, change log. So you can actually see every single increment, what are some of the new features and things that we bring along to the new versions, right? It is entirely optional for you to patch it to patch to a new version. Of course, it's highly recommended, but if you have a factory running on production, you don't have to do it immediately, but it would be good if you schedule a downtime and update them, right? Because you want to keep in line with the latest and greatest from Kepware. So as part of that, that whole roadmap, right? I'm here to actually talk about our latest release, which is the 6.10 release, right? So in version 6.10 in Kepware, right? These are some of the high-level goals that we have, and one of the key things that we want to enable is to enable system integrators or customers to be able to connect to second or third tier devices, right? So so we have a new driver that's released to answer and tackle that sort of challenge that you will face, right? And we want to provide functionality to support enterprise customer deployments. So in terms of how you can actually deploy it faster and support the kind of enterprise environment. And then the next thing we want to do is maintain our top tier driver support. So for some of the drivers that we have, right, some of the current existing drivers, right, we always provide enhancement to them, right? So if you can see on the right side, for example, the Yokogawa GX driver, the ControlLogix V33 update. So these are some of the things that we do to enhance and maintain our top tier drivers, right? Of course, with every release, we will update our system to improve the security stance and enable technical debt reduction. Right. So the first thing that we'll talk about and we will demonstrate later is the universal device driver, right? So this itself is a scriptable driver, right? So for those who are familiar with Kepware, traditionally when we have a device that we are not able to connect to, we will recommend not say connect to, but we don't have a readily made driver to connect to it. We will recommend you to go with the Yukon driver, right, or the CID driver. Right. So each of these drivers do different things differently. For example, the CID driver requires you to write a helper application, right, and requires the use of a shared memory architecture. So you will be sharing memory through the data and write through a mini application, and then we will actually be able to bridge the data through an SDK, right? So in a .NET environment. So that's the CID driver. And the traditional Yukon driver, right, on the other hand, right, is a user configurable driver that allows you to define graphically on how to pass a response message coming in from a device, right? So the most common use of this driver, for example, is to connect to things like metal tornadoes, weighers, barcode scanners, even like GPS sensors, where we can actually take the entire chunk of data and we can break it out and break it into certain things like tag form, so that we can actually populate into the KEPServer itself. So those are the traditional methods. With the current trend of APIs and things like that, we recognize the need for a new kind of driver to complement what we have. So the Udd driver is one of the solutions that we are offering right now. So the key difference between the traditional two of the drivers is that this driver is a scriptable driver. So if you are familiar with JavaScript, right, this will be something that will be familiar to you, right? So what it does is that we are able to we expose some of the method calls within Kepware, our core layer, to the Udd driver, and from there you can actually develop and script out your how you want your calls to be in order to bring the data from a third-party drivers, which will be more complex, So you want to script it to have more flexibility in terms of managing some of the handshakes and things. So we have this Udd driver to bring that data back into Kepware, right? So yeah, basically this is one of the drivers that we will do a deep dive as well later. So I'll just leave it at that, right? But no, this is just a new update, an entirely new driver that was released with 6.10. right? The next thing that we did is the use of the inclusive terminology in our product changes. So PDC as a company has prioritized a company-wide initiative to change the terminology, right? This is in support of a more inclusive and less offensive language. So specific terminologies like master and slave reference will be eventually removed. So you won't be seeing us using that term anymore. We'll be calling, I believe it's client server instead of a master slave, right? And similarly, anything that we determine is not that inclusive or offensive, we will actually change the name, right? So this is just part of the commitment PDC and Kepware has, that we want to prioritize this company-wide initiative to change the terminology we use. Right. So for those who are familiar with industrial automation, usually we use the term master and slave. So just take note that if you see in Kepware, the terminology might have swapped it to client and server. Right. Okay, so in terms of Yokogawa, our GS Ethernet driver, we have actually added support for the Smart DAX Plus product family. So this product in particular is designed for smart data acquisition and control. Right, it's panel mount and paperless recorder. So if you're interested, Google it up, look for Yokogawa GX or look for Yokogawa representative. But in general, we added the support for the new devices, the GX10, GX20, GP10, GP20, and GM10. Right. Next, on the maintenance of the existing drivers that we have, for example, the Fanuc forecast Ethernet. We added two parameters, the CNC RD timer, which allows you to read 5 different timers from device, the CNC RD ALM MSG, which allows you to read the current alarm information, right? So if you're a forecast user today, you can actually edit these two parameters to get even more data. And if you're an Allen Bradley user today, we now support the V33 firmware update, right? So specifically the Compact Logic 530 controller support and the 5580P controller support. Okay, next on the MT Connect driver, which is a way for you to connect to some of the CNC machine, right? We added a property that allows you to skip the schema validation, so that in case you connect to a machine and that particular machine doesn't follow the schema exactly, we will be able to we'll be less strict in terms of how we read and process that XML file underlying. And in line with some of our product roadmaps, we have depreciated some of the drivers. So if you are using Allen Bradley DH Plus drivers, right, just take note that we have depreciated them, meaning that we no longer support them, right? As well as the set bus serial driver. Right, as an ending note, I will update everyone on, I'll share with you on what we view as a roadmap and some of the key themes that we will be following in the next upcoming work year. Right, so in terms of strategic development teams, these are some of the teams that we are looking at. And from these teams, we will develop specific driver enhancements and development on our product itself. So the first thing being maintaining the market leading connectivity for brownfield and greenfield industrial assets. So the important thing to recognize is that we don't support just the new stuff. We also support the less new stuff, which is the brownfield, right? So that at least that gives you the confidence of continue to use Kepware. You can actually continue breach both sides, right? The next thing that we do is that we're going to develop features targeted for the we're going to develop features targeted for the IT and OT market, right? For the enterprise layer. And on the third point, we will evolve our Kepware offering to support more modern enterprise IoT deployment architecture. So one of the specific product will be the ThingWorx Kepware Edge, right? Which is one of our core thing that a lot of our IT customers are asking for. Okay. On the fourth point, we'll talk about the enhancement of remote management capabilities on the Solution Central Edge, which is a new web-based UI to be able to connect to the Kepware that you're running and have an overview on it, right? So that's something that we will be eventually talking about. And last but not least, our key focus is always to maintain the quality, reliability, and security of the software itself. For those who are in the loop, you can see that a lot of OT systems are now being targeted for attacks and having a lot of because of certain vulnerabilities. So we want to continue to do our part and make sure that if let's say you as a customer is in sync with us and you keep your systems patched, we will do our part and you do your part. We make sure that it's difficult for anyone to exploit at least on the Kepware layer. Okay, so for more specific roadmaps, so just as a brief example, in 6.9, which is the last version, right, we supported the Active Directory support. So that's again part of our commitment to support the enterprise deployment requirements, right? So AD support. And if you continue to look at down, we are today at 6.10, right? New drivers, new enhancements, and things like that. And more interestingly, as part of the whole enterprise and cloud deployment, we now have a containerized deployment of ThingWorx Kepware Edge. So if you're looking to have a connectivity that's based on Docker, we have something along that line today, right? In fact, I will probably be doing the demo later. Okay, and on the last part, these are some of, again, going back to our investment teams and some of our strategic priorities, like things that we want to do. For example, the newer UA devices, modern Siemens support. So for those who are, long-time Siemens user, you will know this thing called symbolic addressing, which is something that we will be supporting very, very soon, right? In the next release, I believe. So hang on tight, and we will have something for you. The next thing that we talk about is the remote configuration. So we're going to come out with something that is, easy to manage, web-based, modern, and easy to connect and look at what you have on the field, right? Some sort of asset management kind of thing. And to tackle some of the OT development, we are also looking into how we can support custom data modeling in OPC UA, right? So for those who are familiar with OPC UA, there is a data model layer that is on top of the base OPC UA services. So we are looking for a way to be able to support that in the long run, example, things like OPC UA method calls and things like that. So we are going to look into that, and that will be some of the key strategic priorities we have for next year. And last but not least, driver enhancements for whatever we have right now, right? We want to make sure that we are continue to service them and able to port some of that good stuff in Windows into the Linux version as well. Okay, so that's pretty much the end of the roadmap that I have. Okay, I believe the next portion will still be me. Yeah, before I jump into the next part, again, feel free to just, type into the chat box if you have any queries. Okay, so now I will go straight into the ThingWorx Kepware Edge that I briefly highlighted and mentioned earlier on. Okay, again, I just want to make sure that everybody can see my screen. If you can see it, that's great. If you're not, let me know. So, okay, so for this section, we will talk about the ThingWorx Kepware Edge, right? And specifically the Docker build. So if you remember what I talked about in the earlier section, right? As of now, we officially support the Docker containers, right? So you can actually containerize a version of Kepware, right? And use it to connect to your assets. Okay, so for those who have attended the webinar last year, right? So pardon me because this part will be a little bit of repeating what I talked about last year. Okay, so for those who are new, so this is where we talk about some of the research that we have done and some of the challenges that we identified when we work with the system integrators, right? So the first problem being the demand for digital, right? As the demand for digital, with all this lockdown and stuff, it becomes increasingly important for the machines to be connected and be able to operate, remotely or even by itself if possible, right? So all these things means that you have to digitize a lot of the brownfield systems, right? It's not just the new systems, right? Even the old systems, if possible, you want to start with that, right? And for that to happen, because of that transformation, a lot of the consumers of this data, right, are new to the OT world at least, right? So for the OT people, like us traditionally, I've been actually an OT guy. OPC is like the de facto standard. Usually in the good old days, it will just be an OPC software. It could be a MES, it could be a Scada, it could be a DCS. Something that is bread and butter OT, right? But nowadays, with all these new technologies coming to us, right? We have to embrace them, and a lot of them don't talk languages like those, right? They could be IT centric, right? So those are some of the new destinations that we need to talk about. And the last but not least, specifically a lack of talent, right? So in terms of connectivity, right, some of the system integrators reflected that it's difficult to find people who are proficient in the connectivity layer, right? It's difficult for them. So really, if you really want something that, especially OT protocols done well, right, it is a niche and unique field, right? That's where Kepware has been traditionally being positioned in, right? In some of the cases, the system integrators, right, or some of the customers, right, they develop their own DIY connectivity. So when we say DIY, it means that we hire, maybe a customer could hire their own developers to build their own drivers and things like that. So the key challenge, right, is actually coming in from like the speed of implementation, right? How fast can you bring to market? And the next thing is about ongoing maintenance. Once you bring to the market, right, you need to support it, right? You cannot be just, you bring it and then you just leave it. And then if there are bugs, there's security holes, you need to patch it. So the ongoing maintenance, right? So these two factors alone, requires substantial domain expertise, and as well as experience in terms of developing a good DIY connector, right? And on top of that, with the market moving so fast nowadays, it's an ever never ending evolving requirement, right? So for that to happen, what it also means that the developer must keep up with all these new requirements, right? So for example, a vendor could release a new PLC with entirely new specs, and then you have to support it, right? So it becomes a non-stop race, to catch up with the trends and things like that. Okay. So this is just some of the example of the difference between DIY speed of implementation, right? So comparing, let's say you do a traditional, let's say a modern software development, you'll be doing a couple of sprints. It can take you months or even years, just to get a alpha up or even a beta up running to test it out. If, however, you're using a software, if we have a solution and you like our solution like Kepware, it could be as easy as hours to days. You can download the demo, you configure it, you buy a license from ATS, Sarla, right? And then you test it out, right? And then you deploy it. So we can actually effectively reduce all that hurdle for you to get your connectivity up rapidly. Right. Of course, with the ongoing maintenance, again, with Kepware, every 3 months we come out with a new release. We maintain our software, consistently as a commercial off the shelf, right? We don't build a product and then we just leave it hanging there, right? We build it, we maintain it, and we patch it whenever we can, right? And with some of the, nowadays with all this security and reliability, it becomes difficult to catch up, right? And not just that, when we talk about non-technical aspect, for example, let's say you are running a perpetual license with Kepware. So you buy it, you deploy it, for the next 3 years, there's no issue. And then suddenly some cyber attack happens, you need to patch it. It becomes a nightmare for you because you need to figure out when was the last time it ended support. And then you need to do the administrative work to buy it. And then you need to redo the whole thing, it becomes difficult. So we answer that by having a subscription licensing. So if this is something that you look into and you feel that you want to be, consistently patching your stuff, maintaining and do your due diligence to reduce any form of OT issues, you might want to consider the new subscription licensing with us. Right. So this is just a summary deck of some of the needs that we identified based on the earlier research, right? So I won't go through all of them, but essentially this is how we boil down to what the SIs need. And from there, we answer that with the TKE product, which is the ThingWorx Kepware Edge product, right? So I think nowadays, everything must have IoT, Edge, cloud, all these sexy terms. So we also have this thing called the ThingWorx Kepware Edge. But jokes aside, the idea of the Edge product, right, is to allow you to install Kepware into a thin client and put it into the factory floor as near to the data source as possible, right? So that's effectively what the Edge product is designed for. So some of the features I'll just quickly run through. Out of the box connectivity. So it is the exact same experience or somewhat same experience as our core flagship product in the Windows side, right? You download the file itself, you install it, and you run it, right? The only key difference, right, is that we do not have we call it headless deployment. We do not have a UI for the TKE. And again, the reason is because this product, right, is designed to be deployed on the thin client. So when we talk about thin client, it means that this particular box is going to be very lightweight and very light on resources, right? So you could be installing it like a very small IPC and put it in the factory floor to collect the data, right? So typically, the UI or the higher level interface will be shown, through another software, right? So if you hear what I said just now, there's this term solution central. So that's one of the internal efforts that we are going to do in order to give you some form of tool to actually remote configure it, right? You can also develop your own UI through other products like, our sister company ThingWorx. You could be using Azure to do it, and things like that. So just some of the other solutions, right? The next thing that we talk about is that the TKE itself, or the ThingWorx Kepware Edge, they share the same code base we use and maintain in the Windows side, right? So the same driver used on the Windows side is being developed and made available on the Linux side as well, right? So as of now, right, our current device connectivity, what we offer is that we offer the AB control logics driver, right? The AB control logics driver, the Siemens S7 driver, as well as the Modbus driver. Right? So these are the three drivers that are available today, and we are probably going to release more drivers along the next work year, or 2022, right? So with this latest release, right, which is the 1.3 release, what we did is that we're still doing a lot of the under the hood stuff. So for this particular release, we now officially support Docker. So for those who are not familiar with Docker, I just want to give a brief introduction, right? So with the rise and adoption of DevOps, software are now becoming increasingly decoupled, right? So it's not like the good old days where we have a single software and we try to compress every single thing into it, right? The idea now is not to do that. The idea now is to break everything up into modular pieces, right? Into small pieces, and we call them microservices. And each of these microservices interact with one another, right? And typically they're REST-based. So then what this means for a lot of in terms of software development, right, it allows you to actually be able to rapidly change and adapt to the market requirements, right? For example, today you feel that, there is a new, there's a new patch coming out from Kepware, instead of going through the whole uninstall, reinstall process, you could just tear down the whole Docker container and bring up a new one, and then it will just work like it never happened, right? So it allows you to be shorter build time, test and redeploy cycle. So in order to support that kind of architecture, the MSA or the microservice architecture, right? The key mechanism that we see in the market right now is Docker, right? And for those who are even more familiar, you can orchestrate it with Kubernetes. But again, today we'll talk about Docker first. So this is what we have today, right? So just a brief introduction to Docker for those who are not familiar with it. Or why do we even need to talk about Docker, right? So really the key idea is to keep up with the modern DevOps or even modern software deployment methodology, right? So in this picture, it's just a it's not from me, it's from this particular URL here to talk about some of the different a visual representation of the difference in terms of software deployment, right? So I won't go too deep into it, but if you can see clearly, you can see that the layer of abstraction, is actually going higher and higher, right? You can see that, unlike last time where we have VMs, now we go even one step further with containers. So the TKE Dockerized, right, is a container build of the same ThingWorx Kepware Edge that you know from version 1 to version 1.2 is the exact same product, right? So the only difference is that this is a container image rather than a Linux installer, right? And I will do a quick demo on that as well. So functionally, every single thing is the same thing as the TKE. So if today you are using the ThingWorx Kepware Edge on Linux, you are automatically, you will find that a lot of things are pretty similar. Okay, and for those who are interested, we talk about the future Scada architecture, and then you can actually look for things like this. So this is actually from I believe Azure. So you can see that the intention is for Kepware to be deployed at the edge. So this is what they call the edge L1, level 1 to 4, and this is the cloud, right? So this is the cloud side, and this is the edge side. So what you can do is that you can find a small little box and install a runtime here. And inside the runtime, you can actually deploy Kepware as part of the module, right? So everything can be done headless and remotely, right? So just to share with you, for those who are familiar, in June 2021, which is about a few months ago, we are now officially released on the Azure marketplace, right? So if you are interested, the Docker build or the container, right, is also available in the Azure marketplace. However, the licensing will be routed back to our partners. So, if you are interested in any of these solutions, again, feel free to reach out to Sarla. Okay, so if you refer back to our manual, if you scroll all the way down to Appendix A, we have a specific step-by-step guide on how to run the ThingWorx Kepware Edge in a container environment, right? And also the specific commands that you need to do in order to run it, right? So, I will do a quick demo of this. So what I'll do is that I will take the image, I will load it into the Docker, and then I will quickly spin up an instance of the TKE, right? And after which, at the moment the TKE container starts running, everything else is the traditional TKE ThingWorx Kepware Edge manual, right? I will talk about it as I go along, right? Okay, so if you can see my desktop right now is a big fat blank. So what I'll do is that what I have with me is actually I'll open my command prompt, right? So it's a bit small. I will make it even bigger. Okay, so I have my command prompt here. So these are just some of the Docker commands that you can see. So you can see right now I have Docker for Windows with nothing at all, no container. However, I do have a bunch of images. Oops. In fact, I don't even have them. Okay. So I'm without further ado, I will actually just do a quick demonstration of the procedure on how this is done. So with me, I actually have a C drive, and I actually have a folder called Docker images, right? So I'm gonna just pull it up. Right, so I have a folder here, C drive, and you can see that I actually have a image, right? An image from when you download the demo or whatever it is, right? This is the image that you will get, right? So what I'm going to do is I'm going to load it into my Docker container. Okay, sorry, I'm going to load it to a Docker environment. So it's the specific command is the Docker load command, right? Docker load and then input. I will just make it brief because I'm not here to really talk about Docker, but I just want to show you how this is done. Right, so this is an entirely from scratch kind of situation. So it looks like my Docker is a little bit slow. Okay, there we go. So it has loaded the image. Right. So at this point of time, what it means is that in the Docker container, if you just take a look at the image that we have, like images -a, you can see all the different images that I have. Oops, I typed the wrong command. Yeah, but you can see that I have a bunch of stuff going on. But specifically, I'm looking for the ThingWorx Kepware Edge. Okay, let me make it even bigger. Okay, this is ThingWorx Kepware. So I'm looking for this. This is the exact same image that I've loaded. Right. So what I'm going to do now is, if you refer to our documentation, there is a specific thing that you need to do when you load the Docker build. In the folder where you want to spin up the container, right? You need to bind it to a password, right? So I have a password.txt here. If I double click it, essentially is just a password, right? So this is my password that I'm going to use to start the container, right? Okay, so what will happen is that when I run my next command, which is to start the Docker container to build out of the image, right? It's going to consume that file and use it, right? So again, I'll just put it side by side so that you can see the whole password.txt get consumed, right? So the password.txt is here, and I click enter. And eventually this, password.txt will go away. Looks like it's a bit slow. There we go. So you can see that the password.txt is gone, right? It's being consumed to spin up the instance. And if you look at the response over here, if I just type in this command, you can see that the particular container, right, has been created and is currently running, right? Okay, so this is pretty much telling me, okay, this is great. Everything is running right now perfectly fine, right? So in my computer right now, I have completed the deployment of the TKE, right? Just a couple of commands, you can see I'm pretty much done. So as if anything from this point onward has nothing to do with the container, right? I'm going to just continue the demonstration on what I would do with a standard TKE deployment, right? So for those who are familiar, usually what we need to do is run the HAdmin, which is inside the container, right? For that to happen, instead of typing the command, what I'm going to do is that I'm going to use the shell from the Docker desktop, right? So you can see I have a container running. I will just use the command line to get in the containers shell commands. Right, you can also type this docker exec -it, but this is easier. Okay, so you can see, okay, everything is good. So it will be your standard Linux stuff, right? ls, look at this is what they have. And then nicely, you can see this thing called the HAdmin. If you double click help file, you can see all the available commands. Well, let me make it bigger. Okay, so this everything on this point over is the standard TKE operation that you get from the ThingWorx Kepware Edge manual. Right. Again, I reiterate, this has nothing to do with Docker anymore. Basically, my Docker deployment has been completed. Okay, so I'm going to just finish the demo by doing a configuration demo of the software itself. So the first thing we want to do, remember I talked about the TKE is actually headless, meaning there's no UI for you to configure it, right? So the way we do it is through a bunch of REST calls, right? So for that to happen, the first thing I need to do is actually to be able to do that REST call. So for that to happen, I need to enable it, right? So _admin manage CFG API configuration API -e, right? So that means that it has been enabled. And to make it easy, I'm going to use the less secured version, which is the HTTP version. Enable. Right. So by now, if I do a /h-admin manage CFG API, that's the show, I should be able to see the summary. So you can see that right now, my config API has been configured, right? The port number is this, right? And we are able to start issuing our REST call. Okay. So over here, I have this thing called Postman, which allows me to issue that REST call that I'm talking about easily. So what I'm going to do the first thing is I'm going to use the get method, right, on the project endpoint to take a look at what is the current configuration. So you can see the password is the same password that I typed in the password.txt, right? And I'm going to run a call into this URL, and hopefully I will be able to see the endpoint. what I do is first load. For those who are familiar, what I'm doing right now is the ThingWorx Kepware Edge manual. Oops, apparently the credentials are wrong. I think it's going to crash. Let me try again. Okay, so what I'm doing now, right, is actually in the manual itself. If you look at the commands over here, right, after you finish the standard deployment. So this is the traditional Linux kind of situation where you will download the script itself and make it executable, and then you run it, and then you will install it and everything else. So you can see that just now using the Docker method, we are able to skip all the way until here. Wait, continue on. There we go. So we're actually at this step right now. I'm actually doing the shell into the Docker container, and then we are just doing the configuration, right? So let me just take a quick look at what's happening. So in the meantime, what we can do is we can also spin up another container. So just in case, probably I mistyped the password. So what I'm going to do is I'm going to make a new one, right? A new file. And just double check. Yeah. So it looks like I have entered the wrong password. Okay, let me just do a quick one. Let me just redo the whole thing again. So I'm going to exit this, delete the container, right? Delete the container. And then I will run the same command again, right? So same command. Then I will make sure that the password this time is exactly the same in the password file. File save as C drive, Docker image, yeah. Password.txt. Okay, so now I have a password.txt. Again, I close it, and then I rerun this command. Oh, this is a lot faster now. So it's done. Again, go into the Docker containers, look at the container, look at this guy. We will open the command line again. Right? And then we will do the same thing. CFG. /e enable /h underscore admin manage CFG API --HTTP enable. Double confirm it. Manage CFG API --show. Okay, it's confirmed on, and then we will try to issue the call again. Looks like something's wrong on my demo, but nevertheless, at least we show up the portion of the command that we bring up all the way to the container deployment, right? So it looks like I think I've messed up some of my credentials, right? But that's okay, because that's, if you rewatch the one that we did last year, that will be the same thing that we have done earlier on, right? Yeah. So I guess I will conclude my section over this portion. I think I've overrun a little bit, but if later, if I can get it up again, I'll probably do a quick one. Right. So I think the next section would be, I'll be handing over to Mr. Suresh.
Yes, thank you so much, Steve. We will move to our next session that will be covered by Mr. Suresh.
Yes, please. Good day, all. Hope you are able to see my screen beaming on your screens. Today, we'll be talking about our experiences on this Tech Day with Kepware Discovery Day 2021. We are from the Motherson Group companies, Motherson, Sumi, Infotech and Design. We have a wide portfolios of business, and I am operating from technological and industrial solutions vertical. And we are actually an IT wing for Motherson Group of company, serving our own the IT requirements, starting from shop floor integrations till the complete infrastructure requirement related to the IT requirement. We have been doing that. I am operating from an automation segment where our prime focus is building specific MES solution and point solutions, wherein we are connecting to the data sources. So we are today's sessions will be sharing some of our experiences in using our Kepware services in our portfolios of products. So Motherson Group of companies, we have a different service lines starting from infrastructure, digital engineering services, and we have our own ERP solutions, and we have an industrial 4.0 vertical where I am coming from. And we are serving for most of these industry vertical from manufacturing industries, pharmaceuticals. So the original intention of Motherson, Sumi, Infotech and Design is to serve our own company. Now we have spread our experiences to other customers as well. And we are also one of the certified CMMI level 5 practitioner worldwide in the software industries to maintain our quality and standards intact. So we have multiple different products. We have taken one flagship product of ours, which is an Idax. The reason is that we are using like a bundled versions with the Kipware as one of our preferred data layer, which will be talking on the preferences why we have. This particular product is basically an MES suite. It starts integrating the data floor layer from the OT layer till your GE and GRN till the warehouses. We have multiple module-based solutions, starting from production control, which will implement the checks and balances in the real time of value stream, wherein you want to do some kind of a product validation, like your the child part validation or your sequence validation or your user validation. This module is completely trying to govern those activities on the real-time basis. Earlier, it is only a one-time activity or it is a paper-based activity. Now it has become so digitalized. All the system-driven operations. The advantage of this particular module is that it can integrate to different value streams and try to orchestrate the production in which we can try to implement the checks and balances which we are expecting to pass between the production streams. Yeah. So we have a very key differentiator. This particular model is able to be hosted on premises. and it has a wide flavors to go for on-premises solutions and a cloud-based solution. And we have so designed this software in such a way that it is like a no-code development software. It is only a configuration-based one with a pretty good hands-on computer technologies. People will be able to quickly learn through that. And we are practicing the ISA model, ISA 9.5 model for most of our creation to be so standardized version. So we will be soonly trying to comply to ISA 9.5 as a certifications, wherein the product is able to be integratable for interoperable for most of the other ERP software and PLM softwares. Yeah. So we have some a pretty big bunch of credentials. We have a major OEMs. We can see the logos. We have the credit of these logos on board, wherein we have successfully implemented our product. Yeah. And to add further to our cap, we are also listed as one of the top 40 solution providers in the Gartner's review. And we are also quickly focusing to get into the magic quadrant of the Gartner. So this is our pretty short and brief introductions of our Motherson group of company. And we'll get on to the subjects what we are in with today's tech days regarding Kepware. So why Kepware we are using as one of the preferred data layer? The reason being that it suits as a best operational framework as an interface here. So when we say an operational framework, we are trying to mean that it brings a skeleton ready-made available for us. Okay, we can build our own structures on top of it. So it is not so hard and fast rule that you have to follow some kind of a strict, stringent methodology. It is flexible to change and operate in the way you like. You can size it high, or you can size it low, or you can size it in a flexible manner. You can thread it in a different way, depending upon your operational and system architecture. The second good thing what we see is that it is having an enriched spectrum of device driver. So it becomes a single point of contact for us, wherein you can connect to different sources. Like for example, if your manufacturing suite is almost having 1,000 odd drivers which can connect to, wherein we are happy to connect in one single platform with multiple drivers and congregate this data into a single data layer. Okay, so this is quite a wonderful feature of Kepware what we are experiencing. And one more good thing is that for all these configurations, we are having a single point view. So the single point view orchestrations is a good view wherein you can do and manage things independently. And the look and style of doing this configuration remains almost same for most of these devices which you are trying to configuration. Yeah. So this added benefits, like you can have different plugin services coming into play. As and when we size some of these things in the flow, in the fly, you can keep adding different plugins, like your data logger plugins, or your kind of the different driver plugins. You can just keep adding on top of what you have configured, and it brings an easy platform or a kind of a drawing board for you to design easily for any solution architect to design for any kind of an OT layer. So the challenge here is that when you go into the market, we see like most of these industries are operating with quite a big range of the controller variants. Okay, and congregating every into a data layer becomes a challenge. This is completely avoided with this the complete spectrum drivers, because you don't have to think about that. All the drivers are on board, and you have to just connect it, and you have all the flexibility to connect it, and it is easy for somebody to orchestrate this the creations. So one more thing is that easy configuration, and we find it very easier, and it is taking a very low learning curve for adapting it. I think that any freshers, if they want to start right now, our experience seems like within a couple of weeks time, they can become a kind of a basic user. And on implementing one advanced or one project, probably they can become a medium or to the greater extent of advanced within a span of month time. I think they will become well versed with these kind of tools to handle it. That's what our experience tells about. And one good thing is that these products are off the shelf available. That is also a good thing. If you order, we are getting into very quick delivery time. I think in a span of weeks time, you'll be getting these licenses on board to start your activities. One more good thing what we see from this product is that the hosting environment, it uses a very frugal resources, and it doesn't occupy much of your spaces. So this completely thins your the resource estimate as well for launching the product for production environments. So one good experience, since I think this is going to be tech day long for you guys all, I just wanted to bring in the topmost use cases where we have started with an IoT integration. This we did on 2019, and we were asked by one of our customers to connect some of the data sources wherein we have to connect to a 60-odd injection molding machine, and we were exploring initially with the Euromap connectors, and then finally we landed up with kind of a digital interfaces with this handshaking technology, because there are very primitive informations. Along with the primitive information, we wanted to connect those energies, and we are trying to do some kind of a production and energy-based analysis in the system. And that is a need for us to connect these devices. Okay, and we were trying to use the IoT core of Azure to connect our data layer to that, to create our systems over there where we have our analytical and descriptive layers available. So in the on-premises level, to connect to this IoT, we used Kepware's IoT layer in conjunction with the Kepware's driver suite for Allen Bradley, and we were able to successfully connect it. Okay, and we established this connection using the SAS model for the authorizations of these users. It is a shared authentication, like your token-based services, what you do, and by which we are also encrypting the data for the server, and we have did it successfully. And to our surprise, the implementation was very quick, and we have completed this in the month's time. So one more challenge what we had, we wanted to share with you is that we had a challenge wherein in one premises we need to create a landscape for connecting 600 odd machines, because we have a future of expansion. However, we wanted to maintain a single platform layer. And what we choose here is that we choose us with OPC connectivity suite and OPC manufacturing suite. And we orchestrated the system in such a way that each independent can connect up to 200 odd OPC servers, and we can have one chain master server to play like your client and a client server technology. And we have a bidirectional data exchanges as well, using the databases and ODBC driver links and advanced stack links. I think these are you'll be studying a lot on demo sessions is in the forthcoming series. Yeah, and these are the two major exercises which we feel to share with you, because this orchestration time for developing this kind of an infrastructure, you may be thinking that it may take time, but in our experience, it is not. It was not so great. It was very short span of time we were able to present back to our customers these kind of architectures. Yeah. So these are two major things. I think I'll have a brief sessions to you, and if any questions follows, I think you can just connect me. Thank you so much. Over to you, Pooja.
Thank you so much, Suresh. It was quite interesting. And so next, Steve was not able to show the demo before. So I think he is able to do now. So I'm transferring it to Steve right now.
Okay, with your all permission, I'll drop off. Thank you all. Have a nice day.
Thank you, Suresh.
Yeah, thanks, Suresh. Yeah.
I think that was a very good presentation, by the way. So let me make sure that you guys can see my screen. Yes, you can see my screen now. So I figured out the problem. I don't know why when I when I use the command line here, it seems that it's not working. But right now, so if you can see my code, basically after I drop off, I deleted and rebuilt a container. Right. So it's the same stuff. Instead, now I will be using the command line to shell in instead of the Docker interface. So for some reason, it's not so good. Okay. So anyway, so for some reason, it's not working. So anyway, this is how it's supposed to look like when you send the REST command. So again, remember that at this point of time, we're just using a REST call into the container. So you can see the endpoint of the TKE itself. So what I'm going to do is that you can see that my UA is enabled, but my anonymous login is disabled. So I'm going to just enable it with another REST call, right? So you can see that this is how it looks like. I'm going to change it. I'll send it. And after which you'll be able to see that the system itself, it will work. If I do another call, this parameter has changed. Yeah, this parameter has changed to true, right? So this is how we update and interface with the system itself. So what I'm going to do now, I'm going to create a Modbus channel, and then I'm going to create a device, and then I'm going to create a text. So I'm going to create 2 texts, right? So you can see it's all programmatically done, right? So at this point of time, my Kepware in the Linux, in the Docker container has been configured, right? So what I'm going to do now is I'm going to try to connect to that and take a look. So if you look at my right side, right, this guy is the traditional Windows version of Kepware, right? On the same computer, I have the Linux version running in a Docker environment, right? So I'm going to do the OPC UA connector, OPC UA, so OPC UA, right? And I will connect into the container's OPC UA endpoint, right, with the security on. So at this point of time, I'll be entering the username and password into the OPC UA driver itself, right? So it will prompt the certificate from the container. I'll trust it, and then I'll create a device. So this is session 1.3, right? So at this point of time, when you try to browse it, you will notice that it will fail, and the reason is because the client, or rather the UA server, the certificate is invalid, right? So I need to trust it, right? For those who are familiar with UA, we need to trust both ways. So what I'm going to do now is to trust that license. So again, going back to the shell in the Docker container, we can actually take a look at the command. So if you look at the command, there is this thing called trust store. So that's the command that we are going for, right? So if we go under the /h admin manage trust store, we'll be able to see the commands that is available, right? So what I'm going to do is I'm going to start trusting the client from the Windows version of Kepware. Okay, so that's done by using the admin manage trust store -list UA server. So you can see that right now there is a UA cert, right, coming to the Linux version of Kepware that's rejected, right? So you look at this thumbprint, right? If you go to the Windows version of Kepware, under our UA configuration, you should notice that it's the exact same cert, all right? So this is the UA configuration of the Windows version. If you look at my client certificate, just do a view and go under the details, thumbprints, right? You can see that this matches this, right? It's the same thing. Okay, so what I'm going to do now is going to trust it. And that's done through this command. Right, so now this is trusted. Let's just delete it again. change from rejected to trusted. And what this means is that if I go back to the Windows version and I try to browse the server, you can now see that we can actually see the Modbus tag that I created. Okay. So you can actually even open it a quick time to take a look at the data. Right. So that's pretty much how you will configure the TKE on the Docker environment, and following which I actually did what will happen once you get your TKE installed, right? Either on an Ubuntu environment or the Docker environment. So the commands are actually the same. From the //admin, everything is the same, and they're all documented in the manual itself. Okay, yeah. So that's all I have for the TKE portion. My apologies for the technical issue that appeared out of nowhere.
Thank you so much, Steve. We will have a short break of 5 minutes. Let's meet at 3:22 and we will cover the rest of the topics after the break. Okay, so we will move to our next topics. So our next topics will be delivered by Priyank. Priyank, all over to you.
Yeah, thanks, Pooja. So I think my screen is visible to all. So I will be covering the Kepware major drivers. So let's go with that. So communication drivers and the interfaces. So drivers and the interfaces are a part of KEPServer software. Both are the parts of KEPServer software, where drivers are the data sources and the interfaces are the clients where you require all the data. Okay, so as illustrated in the diagram over here, you can see that these are the driver parts at the below end, and these at the orange part at the above end are the interfaces parts, or you can say that the interfaces with which you can connect to your applications or client. So KEPServer communicates the data sources and devices using wide arrays of drivers, which supports different physical interfaces like Ethernet and serial, and the protocols such as Modbus, CIP, BACnet, or many more. And the same way that can be then after adjusted with the help of means you can have some other functions as well, like tunneling, linking of tags, data logging, security perspective, scheduling, and all those things with the help of advanced functionalities available with the KEPServer. And then after you can use it into your interfaces or applications with the help of interfaces like OPC, MQTT, REST, ODBC, native client, SNMP. So these are the list of drivers and shoots available with KEPServer. There are more than 150 plus drivers available. And here are some of them. So as you can see, DMP3 shoot with 11 plus drivers and 1 to 10 drivers. So it depends on the application you are actually looking for. Okay, for example, you have some application where you need to collect the data from the devices, and then after you need to store into your local store and the tags are limited to, for example, 100 tags only. So you can select the license and the shoots with respect to that, and these are the list of those. Then after, if you talk about the Kepware terminologies for the connectivity, so first of all, it comes to the channel. So what channel is? So channel is the path, or we can say is a driver where we define the protocol or the physical medium. Okay. For example, whether it is a serial physical medium means it's a serial Ethernet or modem, or we can say as a protocol, whether it's a Modbus protocol or DMP3 protocol or IEC protocol. So whatever the driver we are selecting or channel we are creating, so it will be the one which we are where we will be defining the protocol and the physical medium. Then it comes to the device. So device, in the device we will select a model, and then after we can in the device we configure the ID or an IP address, you can say, so ID number, routing path, and the CPU slots. And if it is in serial, then we will select the COM port and its baud rate and all those functionalities. Then it comes to your groups and the tags. So if you have more than 500 tags, or you have some once controller from which you have different system controls, so you can group those tags, and inside the tag those groups you can have your particular tags. So what is the tag? So tags are the unique name within the device or a tag group in which you give a particular address of that particular protocol communicated devices at the shop floor with the KEPServer. And those and with this in the tag you also define your data type as well as the addresses for that particular device, particular controller. So this is what the things which I have explained regarding the terms, channels, and all. It has been reflected over here. So I will just skip this part. Yeah. So now the terms are like Kepserver driver EX, Kepserver EX drivers, connectivity terms, multiple channels. So for example, in a single multiple channels per project. So in one project, if I have I have multiple drivers. For example, one is the Modbus and the second is DMP3. So different protocols I am defining over here. So that is a multiple channels. Then after it comes to single channel and multiple devices. Okay, multiple devices per channel, where I have selected a protocol that is Modbus TCP/IP, but I have more than 3 or 4 field devices which has Modbus protocol, and from those I am collecting data at this point. So now channel threading. So what is the basic difference between single channel with multiple devices and versus single channel, single devices? So in the channel threading, for example, right now single channel with multiple devices, where a client is trying to request data for read and write from both device 1 and device 2. Okay, where your data sharing from whatever the data is requested from the controller to the KEP server will be in a sequential form, which will be known as a series form. First of all, device 1 will go to the PLC and collect the data, then after device 2 will go and collect the data. So this is a basic illustration of queuing of message from device 1 and device 2 as shown over here, as you can see that. So then after, if you talk about the second, that is single channel single device. So here in single channel single device, the client will request the data from both device 1 and device 2 parallelly, because for both we have defined individual protocol. So it will parallelly go to the controller and collect the data. For the more clarity, I will show this illustration of queuing, instruction queuing, where the threads are different for each. So channel 1 device 1 thread is different, channel 2 device 2 thread is different, but the execution pipeline will have one to one parallelly going to collect the data. So what is the benefit of this, of having multiple devices per channel and one device per channel? So in multiple devices per channel, serial devices are usually used and limited bandwidths are there. Then telemetry systems and order of operations are given. Then after one device per channel, devices supports Ethernet. We use devices which supports Ethernet. Plenty of bandwidth is provided. We can use over here. High speed connection and many items to be read. So with the help of one device per channel, we can get plenty of bandwidth, and we can have minimize the loss of data over here, and we can have a high speed connection. So this is not a rule that to go with single channel single device. You can go as per your architecture and as per your use what you have, as per your application. So this is what has been defined over here. So your setup will depend on your system architecture. One device per channel is not a recommendation or not a rule. Okay, it's a recommendation, not a rule. Consider connection type, device type, and protocol and process, and with respect to that only you design your configuration with respect to Kepware channel threading. So in the major driver, first of all, we will go with the Siemens driver. So the Siemens, particularly Siemens TCP/IP Ethernet driver, supports 1024 channels. That means you can connect 1024, or you can configure 1024 Siemens controllers over here with the help of Siemens TCP/IP Ethernet driver particular. So in this particular driver, most parameters which you need to configure is the protocol, that is in the channel you need to just select the protocol, that is Siemens TCP/IP Ethernet, and rest of the configurations are set as a default, which are the standard settings recommended by the Kepware as well as from the Siemens. Then after, while configuring the device, you will have you need to select the model of that particular device. So in the Siemens Ethernet TCP/IP, you have these models S7200, 300, 400, 1200 and 1500. So you can select as per your requirement which controller you need to communicate with. And with this, in the device, you need to provide the IP address, that's the ID of that particular controller. And in case if you have changed some default settings like a PDU size or a port number for that particular PLC, in that case you can you need to change this, otherwise it will be by default PDU size will be 960 for that particular PLC. So other than this ID and the model, all the settings which are given in the Kepware are the standard settings which has been preferred by Siemens. So this was regarding Siemens, and in this particular device, if you are going to make a tag, so what are the main parameters? So that is the tag name which is used for your identification, you can give that name, and the tag address, that is which is associated with the controller. That for example, I have taken over here, the name is tag1 and the address is I0.0. With this, you also need to define the data type of this particular tag, which is with respect to the controller tag address. Then after, the second major driver is the Allen Bradley driver. In the Allen Bradley also we have lots of drivers in Allen Bradley Shores. So one of the driver is Allen Bradley Control Logics Ethernet. It's the same way as the Siemens Shore, Siemens Ethernet TCP/IP driver. So here also the same, we need to select the driver, that is Allen Bradley Control Logics Ethernet, and then after, while configuring the device, you need to take care of the device ID, that is the IP address of that particular controller, and you need to select the model, whether it's a MicroLogix 1400, 1200, or any control logics or compact logics. With respect to that, you need to just select the model, and rest of the other settings will be the default settings. And with the same, if any port number has been changed for this particular control logics, then you need to give that particular port number, if any. Then after, the same way, you need to give the tag name for defining the tag. You need to give tag name, address with respect to the tag defined in controller, and the data type. So now we will jump into the major driver, that is DMP3, which is from past 1 year we are seeing that DMP3 is nowadays widely used. So DMP3 is a protocol for the transmission of data between 2 points and is specially designed for the Scada application. Well, it is highly standardized, compatible, and interoperability between devices from different manufacturers. So this is the advantage of DMP3. And primarily it was used with the electric and water companies, but the main benefit of this particular DMP3 driver is it's same as Modbus driver. Okay, but the main benefit of DMP3 driver is that it has a provision of playback, that is the buffering of data at, between slave to master. So there is, if there is a communication break between slave and the master will receive the data after it gets connected again. So this is the plus point of DMP3 driver. So DMP3 designed specifically for standardization and interoperability, flexible communications, security, strong user support. And as you can see, the communication challenges in the oil and gas and water and wastewater industry that these features specially addresses includes data integrity and reliability. So for the data, particularly as I told that it has a provision of data buffering. So you can use where you have more specifically concentration regarding the data and parameters. So there you can use this particular DMP3 protocol for collecting the data where your data loss is not at all taken care. Then dynamic system environment, standardizing the transmission of time series data, control integrity, remotely monitored widely distributed equipment, regulatory compliances. So this is the architecture we have performed over here in our premises, where some of the flow computers and third-party servers has been connected to DMP3 outstations and with the clear Scada, okay, which is a DMP3 slave. So KEPServer will act as a DMP3 Ethernet master, which will collect data from DMP3 outstations and the DMP3 slave, that is clear Scada, and then after we will be providing the same data to OPC client, Scada or some database. So this is one application we have I have illustrated over here. And for the configuration point of view, if we talk about, for the trial purpose, we have used one demo version of DMP3 server simulator, where we have defined the communication mode and the baud rate. Then after we have defined the IP address and the port number for that. So these are the parameters we need to look upon, okay, for the server point of view. And then after, while with that in server, we will be defining the tags that are binary inputs, double input. So these are the tags which are configured in that particular demo server. Means this is your DMP3 server. So in the now in the Kepware end, we will be defining DMP3 Ethernet master protocol, which will be a client master Ethernet, which will be a client, where we will be defining the protocol, and then after in the device we will be defining the IP address, port number, master address, and the slave address for the configuration of the same to collect the data from DMP3. Then after, with respect to that, I have configured the tags also. So here, as you can see, for particular analog input, the addressing formats are quite different with respect to the addressing format given in server. So here in the addressing format, I have given binary input, okay, but here in KEPServer, for the binary input, it will be 1.0.0. value, okay. So what exactly it is? So as you can see, for each and every data type, it has been defined separately. For example, if it is in Boolean, then it will start with 10. If it is an analog, it will start with 30 analog input. If it will start with 30 analog output, it will start with 40. Then after point, there will be again a variations, and after that variation there will be an indexes, and that indexes will be with respect to the whatever the tags has been defined in the DMP3, and with respect to that the data type. So all those hints can be with respect to that, the hints are screenshotted over here, so you can refer that as well. And all those things has been defined in the help manual as well. So with respect to that, this is my server, and here is the quick client, which is an OPC DA client, which is collecting data from KEPServer from that particular DMP3 Ethernet master driver. So here is a counter input where the value is 123, and in the counter over here also it is 123. But in the next this side, if you will see, there is an analog input, right? Okay, so here you can see the analog input is 0, Okay, so I have changed the analog input to -123.456 and it has got reflected over here as well at the quick client. And same way for the analog output also I have tested, and for the string as well. The string before was high octet string, and then after changing the string, it is high Scada DMP3 simulator. So I have used the Scada DMP3 simulator for testing this particular DMP3 Ethernet driver. So that's all from my side. I would like to hand over to Steve. So Pooja, can you just take?
Yes, thank you so much, Priyank. So our next topics will be delivered by Steve. So all over to Steve.
Hello. Hello, everyone. Let me just make sure you can see my screen. Very good. So in these two sections, I will talk about the Euromap 63 and the MT Connect driver. All right. So I'll start with the Euromap 63. Okay. So for those who are not so familiar with the Euromap 63 protocol, it's a file-based protocol, right? So how it works is that there is a share folder between the machine or the IMM, the injection mode, and Kepware itself. So we share a certain share folder, and then we exchange the data through a couple of files, right? So that's fundamentally how the Euromap 63 driver works on our end, as well as the IMMs, right? So the IMMs refers to the injection molding machine. So this protocol in particular is commonly used in injection mold, right? Some of the issues that we have, or rather the terminology is a little bit different, is the timing, right? Because there is no way, unlike most of the protocols where we can have a request timeout, the timing is not defined in the specification. So the machine itself can take, minutes, hours for it to compile the data. We wouldn't know, right? So the important thing is to play with the timing to make sure that you don't run into race condition where they send the data and then we ask for data and then they say for data, we just raise it, right? So that's one of some of the issues that you may be aware of, that you may run into if you're doing the Euromap 63 drivers, right? So the other thing that we need to note is that the manufacturers themselves have implemented the specification in different ways, all right? So there's a lot of different variances, right? So out of the box, Kepware itself, we actually tested against some of the more common brands of the Euromap 63. All right, and this is just a graphical representation of the typical architecture. So on the left side, what you can see is that this will be what we call a standard, a similar Euromap 63 architecture, right? You can put it in the VM and things like that, and then you can have Kepware going through a software layer where the software itself is performing the Euromap 63 sharing of data, right? So you can see that the key difference between the left side, the key difference between the left side, right, is that we in this section we have a vendor application that is connected to its own machine using its own protocol, and they are interfacing through us using the share folder using Euromap 63. So this is one example of a situation where how we can interface with the machine, and in the other scenario we can actually talk to the machine directly, right? So this is a case where we do direct to the Euromap 63, and typically in this scenario, right, you will be configuring the parameters in the machine HMI itself. For this case, usually you have to install a software agent or something like that, and then we have to use that machine to create that, to connect to us through the share folder, right? So in terms of the feature, right, what this driver does is that it allows you to have real-time data access to Euromap 63 enabled injection molding machine, right? And of course, on the other hand, we also allow you to do writing capabilities. It's a read writing to the standard to the following Euromap 63 data types, right? On top of that, we also allow you to do automatic tag generation using the get ID file, right? So we can actually request and poll for what is available or what parameters are available on IMM and generate the text automatically. right? So if you look at the right side, these are some of the out-of-the-box supported device manufacturers. So these devices are some of the devices that we have tested against, right? It doesn't mean that if your IMM is not in this brand, it will not work, right? There's a lot of brands out there, but these are some of the available machines that we managed to test against. Sorry, to test against. And no, just for sharing, right? This is actually how a typical Euromap 63 exchange will occur, or a session will occur. So Kepware itself, right? We will initiate a job request and a session request. All right. So we will send on the driver layer. Once you open the quick client, once the driver goes active, we will start this, right? And it will be dumped to a specified share folder, right? You will need to specify where is that share folder. And what will happen is that the IMM itself will actually read and recognize that and respond with the session response, the job response, and the third file is the data file, right? And once this is done, right, what will happen is that the IMM will actually get the data and they will delete the session request. They will delete this file to indicate that the job has been completed. They will consume it. So once the data is gone, what will happen is that the rest of the data will then be auto-populated into the Kepware, right? So we are going to see this in a short in a session later on, right? Once I finish this. So on the comms diagnostics, if you are interested, this is how we will represent the data, right? You need to swap it to ASCII and you can see the different underlying ASCII representation of what are the files that we consume, what is inside the file, and what is going on between the Euromap 63 layer. Right. So with the launch of this driver, just bear in mind that we actually have two documents. So the first document is actually using the to look at the Euromap 63 standard, and the second one is to look at the device diagnostic output. Right. So I'm going to move on quickly to the demo. Okay. So over here again, this is the same Kepware that we connected just now using the OPC UA driver. So now what we're going to do is that we're going to use the Euromap driver, right? So if we look at the Euromap driver, it's over here, and I'm going to just call it EM63. Okay, so most of the configurations are pretty straightforward, so there's nothing much to go for. It's a relatively straightforward driver, to be honest. So I'm going to say IMM, right? Device name is IMM, and I'm going to just leave most of the parameters as it defaults, right? Until this part. So this is the part where we need to define where is that share folder. All right. So for this particular instance, I will be using this a desktop folder. All right. So I just want to show you guys the folder itself. Okay. So I have an empty folder right now on the left side. So what I'm going to do is that instead of connecting to an actual IMM, I have created a bunch of response files that will be simulating the response manually. All right. So if you look at the understanding the device diagnostic folder from Kepware, you will also be able to follow these steps as well. Right. So what I'm going to do now is I'm going to disable the get ID, remember, to populate the text. So instead of that, I'll just disable the validation because it's demo, right? So this is pretty much where we'll end it, and we'll add a text, right? So instead of populating automatically, what I'm going to do is that I'm going to do a manual one, right? So the first parameter will be this, and the address is this, and I'll call it, and this is string type, and I'll create a second tag, which is this, and string type. Okay. So pretty much I've completed my configuration of the channel, device, and tag. So I just want to make sure, I just want to do one more thing before I start the driver itself. I would like to enable the diagnostic capture, right? So that I can show you the underlying cause as well. Right, so at the bottom right corner is the diagnostic core, and on the top corner is the Kepware. All right, so what I'm going to do now is I am going to start the driver. So you will notice that the moment I launch the quick client, is going to cause the driver to be active, and we will be able to see the job request files, right? So once that appears, what I will do is that I will copy the response file to simulate the IMM, and I will consume that request file that we talk about, right? So I'm going to just launch quick clients. You will see that the driver itself started, right? Then I will paste the response file, right? And I will consume it. So you can see that the second job ID has started and the previous results has been populated over here. All right. So that's pretty much how the Euromap 63 driver works in a very high level overview. But I want to point out I want to point out what you can see in the comms diagnostic. So in the comms diagnostic, if you swap it to ASCII, you'll be able to see what is the underlying different cause. So again, based on the previous demo, we can see that the driver itself have went to this folder, created the job 0000R000.job, and then we also created the response and things like that. And then once this is the session request file. Inside the session request, these are the contents. Okay. Then what happens is that once we responded, we have the response file, and we trigger the consumption of the response file by deleting and removing the request file, right? And once that happens, what it does is that it consumes the .dat file, which contains the data for the text created, and then it populated back onto the OPC client, right? So in this manner, we are able to connect to the IMMs and have the data presented to you in a timely manner, right? So that's the EM63, short and sweet. And the next driver that I'm going to talk about would be the MT Connect driver. Similarly, this is a pretty short driver overview. Okay, so the previous driver Euromap 63 is a protocol that is highly used in injection molding machine. The MT Connect is a driver, right, that is prevalent in the CNC arena, right? So there is a certain standardization going on with the CNC side of things, and it's called the MT Connect, right? So this MT Connect is actually maintained by the MT Connect Institute, and they are open and free to use protocol, right? So a lot of times the machine builder or the CNC machine can actually define what is being exposed through this particular protocol, right? So these are some of the brands that offer and support this particular protocol itself, right? So version 1 is released in 2009, and the latest version 1.31 in 2015. Upcoming, I believe there is a companion spec coming in from OPC UA. The protocol itself is in general very similar to SOAP. So it's just based on HTTP transport, and it has an XML payload, right? So if you look at the right side, that's an example of the MT Connect XML file, right? So this is how it looks like. And for KEPServerEx, we support the version 1.1, 1.2, and partial support for 1.3. So in a typical architecture, you have a machine, and the machine comes with the MT adapter. So this MT adapter could be, could be a hardware, could be a software. It depends on how the vendor implements it, right? So very similar to Euromap 63, where we saw that the Euromap 63 agent could be a software, or it could be built into the machine itself, right? So you need the adapter going on. And then on the next thing that we need is the agent, right? The agent is again, is defined by the MT Connect spec. And this agent is the software or hardware that we are connecting to, all right? So there is an adapter that collects the data, it maps it into the MT Connect data items, and it pushes it to the agent. So when we connect using the MT Connect client, as an MT Connect client, we are connecting to the agent itself, all right? So this is an example of Mazak, who supports the MT Connect systems. So you can see this I directly copied through their website. So if you're interested, you can check out their link and then take a look at some of the protocols or how they implement or what machines they have that support this. Right? So you can see that it's very similar to the previous picture I showed. There is an adapter, there is an agent, and the client software will be Kepware. Right? So we can have Kepware connecting to their agent, which then passes and talk to the adapter, which is I believe it's the hardware, and then connect to the CNC machines. All right, so for more information, again, you can check out the MT Connect Institute link. And for the demo, I will be using the simulator agent, right? So there is a public available agent that is available for demonstration from Mazak actually, right? So this is the parameters that I will be using. If you are interested, you can check out the web link, right? In fact, I'm going to just probably show you so that it's much easier to talk about. So if you go to your browser, and you just open the link that I talk about, you can see that we have the demo agents from Mazak. Okay, the one that I want to connect is this guy. Okay, or rather the demo I'll be doing. So if you click it and open it, you can actually see the XML file that we talk about. So this is the agent response for the XML file. And what it does is that Kepware will actually read it and consume it and convert that to a tag form. Right, so that's what I'm going to demonstrate right now. So the first thing we want to do is, again, in true Kepware fashion, we'll create a channel. So we'll just use the MT Connect driver, which is here. Okay, MT Connect. Again, default adapters. Right, finish, very easy. The next thing we want to do is the machine. So how do we know the machine name? If you look at the XML file, if you actually bother to just run through it, you can actually see a lot of stuff. So you can see that the device name is actually this. And then for this portion, you can see that I need the device name to be this. And for the IP address or host name, I will be using this. Right. So the rest of the stuff, I'll keep it as default until this part. The port number is 5609. Okay, so once I'm done, I can actually double click this and go under tag generation. So what it does is that when I click create tag, it will reach out to the agent and grab this XML file, and it will generate the tags for you. Oh, so it's done. So you can see that it's pretty fast, right? So you can see in this particular agent, we have this machine, we have the path, and all the different parameters, right? So I'll just launch quick client for you to take a look. Right, so you can see this data is in. Some of the data are probably not there, right? So some of them are working. You can see all the different parameters about the CNC machine, right? So you can see that actually with KEPServerEx, it's quite seamless to connect to all the different machines that you have. Like what Suresh said from Madison, he has shared his experience with you. It need not be overly complicated, right? With a tool like Kepware, you can actually quickly connect to all these machines relatively easily. All right, so that's the end of my MT Connect demonstration. All right, if you have any question, feel free to reach out to ATS Sarla Advantech for more assistance on this. And I will just move on to the next section, which is the Udd driver. All right. So for the Udd driver, let me just open up my PowerPoint. So the Udd driver, as I mentioned earlier on during my first presentation, is a new driver that comes with 6.10 and above. Okay, if you're upgrading from any old version of Kepware, just remember that during the installer, you need to explicitly check the box to install this driver if you're using this. All right. So I will just do a run through of the overview, as well as talk about the limitations of our first current build and some of the things that we can do, as well as doing a quick demo of how the Udd driver is, how to use it. All right. So what is Udd? The Udd again is a scriptable driver that is based off JavaScript, and the goal is for us to provide a scriptable driver which offers you the flexibility to code and provide a connectivity solution in order to reach out to second tier 2 devices or even any of the APIs, right? So what this does is it accelerates the driver development for you. So in the event that we do not have a driver, however, you know that there is a way to interface it, maybe through a REST call. It could be a custom protocol that's easy to script out. You know, this could be a solution for you. Right. So in terms of overview, this will be the software architecture. So when you install the UDD driver, just take note that there will be a new runtime that new process that will appear in the Windows task panel. So typically we have 4, right? So the runtime, the admin, the config, and the event log. So now we added this script engine on top of the, if you're using the plugin, you know, you also see the IoT gateway and things like that. So the UDD driver itself will have its own runtime as well. It's a script engine, right? And installing the UDD also adds in 3 new components into the interface itself, right? There will be a library plugin as well as the UDD driver. Okay. So there are some terminology that we need to talk about when you develop your UDD drivers. The first thing being, what is a profile, right? A profile is a script where you can copy and you can load it in that will be run when the driver instantiates itself. When the driver, once you define the driver, you link it to the correct profile. So you can see the profile itself, there is a GUID here, which is this string over here, right? If it links to this ID, and it will load the script itself into the runtime. So that's what essentially your profile is. So if you're familiar with this, you know, in the Yukon terminology, we have the same terminology called Yukon profile, right? It's the same thing, right? So the profile, right, itself, right, it can be used to by multiple channels, and each of these channel, right, will, when they launch and instantiate itself, will be in its own context, which means that the variables do not affect one another, right? So you could create multiple channels, and when they load the profile, whatever is in that profile is in its own context. It will not be flow over to the other channels or profiles and things like that, right? So they get their own space or address, as some of the programmers may recognize. Now, because this is our initial launch of this UDD driver, so these are some of the limitations that we have. As of now, this driver only supports solicited Ethernet drivers only. So if you're using a serial driver that is trying to handle an unsolicited communications kind of protocol, you're out of luck with this guy. So what you do is that you roll back to Yukon, right? The other thing is that currently what we do is that each channel can only support 1 device. So if you've got 2 devices, you need to create multiple channels. Okay. Then on top of that, these are actually some of the other limitations, like single send, single receive per property update. So if currently when we read the data, right, it's not a block read, meaning that once we get a data from the response file, we do not pass the entire data. We'll look for the data that you are looking for and load it into the tag. So this might not be that useful in certain use cases, but it should fit in some of the driver use cases. All right. So really, when you want to use UDD, you know, please reach out to Sarla so that we can understand and help you with this, like whether it makes sense to use the UDD driver. All right. So I'm going to just do a quick example of this, and just to share with you, when you install the 6.10 and the UDD driver, there are examples included in the Kepware program folder, right? So you just need to load any of them, and you can actually run through. If you want, you can Google up this document, which is a connectivity guide for the universal device driver, and then you can take a look at the how to develop the driver with Modbus as an example. So for those who are interested, what is going to happen is that I will take a HTTP example and quickly, run through the code, and then I will demonstrate how do we load that into the UDD driver and pull data from an API. Okay, so without further ado, I will quickly load the script. So the script itself is essentially just a JavaScript. All right, so I'm just opening it. Okay, so I'm using the an IDE called Visual Studio Code to to quickly show you how the code itself looks like. Oops, sorry. Okay, so you can see that this is actually one of our HTTP sample code. So you can see that this is the driver info function. So remember that if we look at the deck earlier on, there are four major functions that you need to code in. Right. So the first get driver info is really just information about the driver. So nothing too fantastic. The next thing you need to do is you need to validate the address. So what is this address we are talking about? This particular address refers to the Kepware address, right? So if you launch the, when you launch a Kepware, you create a channel, you create a device, and then you create a tag. What is underlying on each of the tag again is the address. So for example, in this case, no, this is a bad example. Okay, let me find something. Okay, so for example, this tag is called my tag number 2, but the address is this. So when we are doing a validation, we are just on the driver layer, do a first cut to confirm that the tag itself is valid. All right. And then the next thing that you will do is the build message, right? So build message is used to when the tag comes active, right? How do you want to transmit the data, right? So this is the build message, or what we call the TX transmission, right? And if you go back down, the next function is called pass message. So once you get the data back, how are we going to handle the response file? So we handle it using a script you can read and take out. So in this particular use case, a JSON payload will be responded back to us. And in our code, what we'll do is that we will match the tag value to the specific response from the JSON payload. Right. So I hope that makes sense to you guys. So as a demonstration, before I go further, let's test out the API itself. Right. So similarly, I'm going to launch my good friend Postman and issue a GET request into the API itself and see what comes out of the API. Okay, so this particular API is under the Open Weather API. Okay, so you can see that we just launched to this URL, and then if we send, we will get the following data, and the data itself looks like this. Right, so it's a JSON representation. And if you launch back the code, right, you can see that what we have done is that we used a regex extraction to a regular expression in order to validate the tag itself. Right, so in terms of if you look at the JSON response, what we do is that we have flattened it. So if you want to get this tag, just call it at the root, at the first tier, right? We just call it visibility. If you want to get this, there is underlying another JSON object. So the syntax will be win _speed, right? And similarly, if you want this, it will be win _degree and so forth. Okay, so this is exactly what we're going to do now. All right, so we're going to use Kepware to pass this data using the Udd driver and bring it into Kepware. Right, so going back to Kepware, so the first thing we want to do is to create that profile, right? So if you look at Kepware, right, there's this new thing called the profile library. So what we're going to do is that we're going to click it, and I'm just going to call it Open Weather because it's actually an Open Weather API. And then what we will do is that we will import this script itself into Kepware itself. Right, so let me just close this first. Under profile, browse for it. Okay, so you can see now it's completely populated. I'll click OK. So now the profile itself will be populated with the GUID, right? I'm going to just copy the GUID, click OK, and I'm going to start creating the channel. So again, the channel goes under the UDD driver, Universal Device, UDD, and I'm going to paste in the GUID. Again, the GUID links the profile into the channel, right? The profile into the channel. And once this is done, I will start creating the other stuff. So this is actually open where the map, I believe. Okay, so for the destination IP, we need to set it to the URL itself. And the port number will be port 80. Okay, so that's pretty much the device. And then we will create the text. So this will be visibility. And then let's create a couple of them. Win double dot. Okay, and then when we launch the quick client, you can see that the data will be coming in soon. Oh, I believe I need to restart my runtime. Give me a moment because my demo license has finished. Okay, so in essence, this is how the profile will look like. You import the script, and then you link up the GUID to the UDD driver channel. So it's under the device, under the channel. Oh, sorry, under the channel, and then make sure that this is the profile, and then you can create a text. Right. So what it does is that if the text is not validation, you will see the validation error and things like that. So you can see that in at this current time, you can see that there's no text created is because there is a validation error. Right. I use the default tag, which is wrong data type. So what I'm going to do is I'm going to close this, and then we will swap this to string. And once this is validated, you will no longer see the error, and then you should be able to see the text created in your client. See that? So this is the wind speed and visibility coming in from the API itself, right? So this is an example of how you will use a UDD to connect to a HTTP server. So in this particular use case, we are using the UDD as a HTTP client to a HTTP server, right? So at this moment of time, if you are curious, HTTPS is not supported yet, but it's in the pipeline, and eventually we will release a build that supports that, right? So there's a certain limitation to the driver in our first release, but eventually we will improve it, and fit in more use cases. And that's pretty much the end of my UDD Euromap 6.3 and MT Connect presentation. I will handle the next section to Nilesh, I believe.
Yes, thank you so much, Steve. We will move on to our next session, and that will be covered by Nilesh.
Thank you, Pooja. So good afternoon, everyone. So I am Nilesh Jangle, and I will be going through a couple of KEPServerEx plugin topics. So we'll start with KEPServerEx Advanced Stack plugin. So So KEPServerEx advanced stack plugin is quite widely used plugin available with the set of plugins in the KEPServerEx. So obviously, this plugins provide certain advanced functionality on top of the data which is collected in KEPServerEx, certain topics which are mentioned by like Priyank as well as Steve, the drivers which are mentioned. So once this data comes to KEPServerEx, there are certain plugins which are available with KEPServerEx. We can have certain advanced functionality with those plugins. So we'll be talking through advanced tags. So advanced tags can be used with any static stacks. So basically Kepware driver supports two types of tags. One is static tag, which is configured, and another is dynamic tags. So typically advanced tag can be used with static stacks, and it can make that information more suitable for high level analysis, so that more meaningful information can be used for analysis purpose. So obviously advanced tag enables like machine to machine tag linking. Like you can have a linking of the tags between two different machines, two different protocols. Then you can have logical or mathematical functions for operational communication and analysis. And obviously there are a variety of tabs or types available with the advanced tag. So if you see here, these are the types which are available with the advanced tag. First one is link tag, which is used for linking the tags from machine to machine or protocol to protocol or PLC to PLC. Derived tags, where you can write the expression. Complex tags are there, which will have which is mainly meant for Oracle MOCs, but it can be used by other client itself. Like it will provide you one string format, XML formatted string, like concatenating the specific tags. Then minimum, maximum, average, as name suggests, they do minimum, maximum, or average functionality. And Oracle cumulative also another type which is available with the advanced tag. So we'll discuss through each and every type of this advanced tag. So first we'll start with like link tags. So what link tags does, it like transfer data between two existing tags in the server. So for example, you have configured two channels in the KEPServerEx. One is Allen Bradley PLC, another is maybe Modbus or Schneider PLC. So from Allen Bradley PLC, you want to link certain tags or a particular tag from Allen Bradley PLC to certain Modbus register to Schneider PLC. So that can be done through this link tags. So there are two types of configuration. One is input, another is output. So in input, you can see over here, we have mentioned this Allen Bradley tag, double array tag, and in output, this Modbus PLC tag is mentioned. So depending on the static interval or maybe expression or trigger condition, this input data will be returned to the output data. So this is very useful in case of communicating or linking the tags between two different protocols, and this is not restricted to Allen Bradley or Modbus. You can use whatever protocols is supported with KEPServerEx. There are almost 150 plus communication protocols. So you can use this functionality to linking the tags between two different protocols. And obviously, it can be configured to occur always or only when certain condition meet, like static or specific beat or trigger condition. And link tag can be used for many different applications. So triggering cooling process if device temperature goes too high by linking data to chiller system. So this is a very effective example for a link tag. Or even link recipe data from SQL database to PLC, like using KEPServerEx ODBC client driver, which is I think one of the topic which Steve is going to conduct. We can take certain data from SQL and link that data to maybe PLC for certain recipe changes. So this is very useful, link tags. Then why linking is required? Obviously, there is no way we can have data server to data server linking or communication, or even two different mix of PLCs communication. Obviously, there are certain hardware devices or maybe programming, but that is very complex. So linking, so with linking solution, there are like three types of solution. One is OPC server bridge, another is OPC server aggregator, as well as OPC server within server bridging. So we'll talk through this OPC server bridge. Like there are two OPC server in this example. So here there are two examples provided. One is link master solution, another is advanced stack solution. So link master is altogether a different product, and advanced stack plugin, as we are discussing, it is one of the plugins available with KEPServerEx. So if there are two OPC servers, link master can be used to link these two OPC servers, that is OPC server bridge. Similarly, advanced tag can be also used to link these two tags. Typically with OPC DA or UA client driver, you can create two channels, and then further you can use this two OPC data servers for bridging purpose using advanced tag link tag type. So this is one of the types of solution. Another is like OPC server aggregator. Like you have multiple OPC servers, say OPC server 1 to OPC server 4, or maybe number of OPC server. You want to provide this data to specific OPC client, and now you want to aggregate that data to one system. So in that scenario, link master as well as advanced stack both can be used, using, obviously in case of advanced stack, it is more maybe efficient, as we are having this connectivity or driver as well as plugin inside one component itself. There is no separate software required as a link master. So this is there, like DA UA client driver can be used, and advanced stack plugin can be used to just aggregate the data coming from different OPC servers. Then obviously one of the most useful use case will be to routing data between two PLCs. So this is commonly used, and most of our customers are using this link tag functionality for OPC server with server bridging. So this is very helpful and easy in case of advanced tag. And this is just an maybe comparison between link master software and link tags functionality which is available with the advanced tag. Obviously link master can communicate, communication must go outside the server, obviously. So this is a link master product that communication has to go outside the server, because this is a different product. So it has built-in DA client functionality. So it depends on OPC server only, like your source has to be OPC server, then only link master can be used, and there are no mathematical or logic functionality. So obviously with advanced tag, communication happens within the same server, KEPServerEx itself, and you must purchase OPC client driver to connect with OPC server. But apart from that, whatever drivers you have purchased, that functionality will be always available to be used in advanced tag. And other advanced tags types which are there, mathematical logical functionality, can be used along with link tags. So it is not only linking, you can have trigger condition based on certain derived tags or certain expression which can be used for advanced tag. So if you see like next type, so we have gone through like link tags. Now next topic is like derived tags. So derived tags are again very useful because you can use various logical operators or mathematical operators which are shown in this specific slide, like equal to, greater than, less than, even and or those conditions, or simple mathematical operators, even sine, cosines. So this can be used in creating expression which can be used with derived tag. So this expression can be created using the values or quality of the system tag. Even we can use values as well as quality, as each OPC tag will have a timestamp, value, quality. So you can use those parameters also inside expression. And best example will be like temperature conversion, or even calculating the power factor, or even like giving certain overweight alarm, like actual weight and maximum weight. Those can be compared with this logical parameters, and then alarm can be generated. So there are many examples or use cases with the derived tags which can be used, and it supports all these operators. So this is again useful, derived tags. Then complex tags is another type which is available with advanced tag, and it is mainly used by Oracle MOCs, and it basically unifies several tags into one complex XML structure. So as you can see here, right hand side, there are like tags coming from specific line or maybe area, PLC area, with date, or certain Boolean tag statuses, or maybe certain float tags with speeds, or maybe some other production counters. So you want to have one complex structure when MES or maybe MOC kind of systems, they are reading this data. we don't need to, or that system don't need to read each and every tag. So they want it in a single structure itself. Then complex structure can be used, but obviously this will provide data in XML structure, all this data in single specific string. So this is a string data type, complex tags. So this is again useful. And then obviously minimum maximum tags are again useful in case like somebody want to basically calculate minimum or maximum value of specific parameter, maybe temperature or specific duration. So it uses basically one trigger tag. You can see here in run condition there is one trigger tag, and this is the tag which we want to calculate as a maximum. So this will basically your input tags. And then once this trigger condition value becomes non-zero, from 0 to non-zero, it will start calculating the maximum or minimum functionality for that specific tag. And once that again trigger tag becomes to 0, it will stop calculating our maximum or minimum functionality for that tag. So this is very useful. Similarly, there is a tag called as average tag, which is again can be used with similar logic, similar run tag, trigger tag, and this will calculate average of that specific tag. So every scan it will maybe use that tag value, and it will keep on calculating average for that specific tag until this run tag is non-zero. So we can use this for averaging specific tags. And final tag, which is like Oracle cumulative tags. So this is again meant for Oracle, but it can be used by any other OPC client application. So Oracle cumulative tags enable you to determine differences between your tag's current value and its previous value. So when we say difference, it is basically absolute different. For example, there is like this tag, which is like we want to calculate as a cumulative, and this is maybe counter, which is ranging from 0 to 100. So first scan, every maybe 1 minute we are fetching this data, and for first scan value is 5, second scan the value is 45. So my cumulative tag value will be difference between my second scan and first scan, that is 45 minus 40, that is 45 minus 5, that is 40. Third scan it is 95, so again it will be like 95 minus 45, that is 50. And in fourth scan, if value is 4, so when we say like it is an absolute difference, it will basically go through this calculation. So it is like 4 minus 95 plus 100 as my low and high limit. So that absolute difference will be depend on your higher like range or limit. So it will be 9. So this is also useful in some cases. So these are some of the types of advanced tag, and it is widely used, and this can be used along with any of the channels configured alongside KEPServerEx. Even it can be used in any of the other plugins which are available with KEPServerEx, maybe database logger or maybe some other plugins which are available with the KEPServerEx. So if you want to do certain basic level calculation or aggregation of data, so this is very useful advanced tag plugin. So this is a separate purchase available with the KEPServerEx. So maybe we will go to our next topic, that is SNMP plugin. So SNMP stands for like Simple Network Management Protocol, and basically it is openly and widely adopted standard when you connect network devices. So network devices like UPS or RTUs or switches. So most of these devices, when they are smart devices, they support this SNMP protocol. So this basically SNMP agent plugin, it is mainly used by IT administrator on IT domain people or even network administrator when they want to have this network management systems. So this specific SNMP plugin enable network administrators to manage network performance, obviously detect certain network problems, or obviously optimize their network. So application layer protocol, this is like application layer protocol, which is part of transmission control and internet TCP/IP protocol suite, and it is maintained by Internet Engineering Task Force. So in device layer, which is like there, and network layer, basically this UPSs or maybe powers like RTUs or switches, those kind of device, they typically have SNMP agent, and so those can be used. But this specific protocol or plugin which is available with SNMP or KEPServerEx, we'll talk through this. As you can see here in right hand side diagram, like different data sources coming to KEPServerEx. It might be PLC, OPC server, databases, or any other source. Now data is available with KEPServerEx, and using SNMP agent, we can provide this data to any network management system, because this network management system will only understand SNMP protocol. They will not understand Allen Bradley or maybe Siemens or OPC, DA, UA, those protocols. So whatever data we have at KEPServerEx, that can be provided to this network management system to further analyze the network in efficient manner. So if you see here, it can access the automation system and devices, monitor network attached devices for condition, even avert or remedy fail to internal processes with certain unexpected external events. So like alarms or certain traps can be even provided. So if like network management system administrator want to see more detail of the data from the device, then these devices which do not speak in SNMP, this can be converted to SNMP, and then it can be provided to network management system. So one of the example maybe like if in NMS system we are monitoring the network, but we want to see the timestamp. This is just example, but there might be any other parameters which are important, or maybe some IO model diagnostic parameter, or those kind of parameters can be read by this NMS system and displayed on their maybe front end, which will make more sense of analyzing the network data. So this SNMP agent plugin does that, and obviously this diagram illustrates the same, like giving IT access to PLC and device health. Because as these devices like Allen Bradley PLC or those devices, they do not like or even network management system, they do not know this protocol or PLC health. So that can be also monitored along with the network management. So which will make more in-depth analysis of the like your overall network as well as system. So using this SNMP agent, it is possible. And obviously, so these are some of the features, like it provides your plant data on NMS to NMS. So typically this network management system or SNMP protocol uses MIBs. So so this is like some of the objects or tags parameters and even traps to give certain alerts or alarming condition, which is like unsolicited communication. So both these things are supported with SNMP agent, so that it can be used by NMS, and it can gather any data out of this 150 protocols, which leverages basically OPC communication through KEPServerEx. So this is very helpful, and it is mainly used by IT administrator for network management systems. So I think yeah, so that's it from my side about like advanced tech plugin and SNMP plugin. Over to you, Steve, for upcoming topic.
Thank you so much, Nilesh. We will cover our next topics. So Steve will be delivering our next topics.
Hello. Let me just get my screen correct. Let's close this. All right, so the next topic that I will cover is the IoT gateway. Right, so for those who have attended last year, I believe I did this. It's going to be the same presentation, but for this year, I'm going to do a different demo. All right, so the last year, I think if you are interested, you guys can reach out and look back. I believe we did the Telegram demo. Right, so this year I'm going to do the other demo, which is to IBM Watson. Right, so I'm going to cover basically the IoT gateway and the data logger for this section of my presentation. So just to have a background on what is this IoT stuff going on. It's actually, it refers to the Industry 4.0 or the IoT stack. It's first coined in 2011 by a German government to describe the manufacturing digitization project, right? So basically it means the convergence of physical and digital systems in industrial manufacturing, right? So if you're interested, you can read more about this, read more about our take on the I4 and IoT, right, at the following link. I won't go too deep into it, right? If you recall back into the earlier presentation that I did, remember that I said that connectivity is one of the foundation and enabler for digitization. So in a lot of sense, this still rings true in the IoT section, right? So in IoT, the concept is that we have a lot of data, right, and they can be represented through things, right? These things could be a digital representation of the machine or device itself. And then what we'll do is that we'll leverage internet technologies and pass the data to cloud platforms, which then can leverage the cloud services to deliver new capabilities to the OT section, right? That's not previously possible, right? So at the end of the day, in Kepware's perspective, it's all about data, right? So as a reference, right? So for those who are familiar with the ISA 95, this is how what we see in terms of a disruption and how we view a typical IoT architecture, right? So typically you have the edge portion, where you can install a thin client. Remember that in the earlier section I talked about the TKE, which is the ThingWorx Kepware Edge. They can actually be used in a scenario like this, right? You can load Kepware into a thin client. It could be a Linux-based, a light IPC or anything like that to connect to them, and then we send it to the cloud, right? So for the Windows version of, or rather both versions of it, we have this component or plugin called the IoT Gateway that allows you to do just that, right? So you can use Kepware's drivers to connect to Scada, through OPC-DA. You can connect to meters and power meters, industrial PLCs through things like Modbus or the native protocol. You could connect to the IMMs like EMs using Euromap 63, which I talked about earlier on. We also can connect to CNC machines using MT Connect, right? And then we can get all the data in. Once we get all the data in, we can then send it to the cloud platform for further processing, right? Or we can also log it into a ODBC-based database, which I'm going to demonstrate later as well, right? So for the IoT gateway, essentially what we do is that we added the IT-centric protocols into this plugin, right? So the REST client, the REST server will be the HTTP protocol, and the MQTT agent will be the one that's using MQTT, right? And lastly, we no longer have ThingWorx agent, so just skip that one. But at the end of the day, the underlying data payload, they're all JSON format, right? So for those who are not familiar with JSON, it refers to JavaScript object notation. It is an open standard that is defined, and it looks like the picture over there. It has two curly brackets, and inside the content, there is what we call a key value pair, right? So it's a human readable text, and it can actually be passed through different APIs, right? So as long as you are doing some sort of programming, you can actually understand this JSON payload, and you can see, and you can actually use it to get what you want. Okay, so for those who are in keen, when we talk about HTTP, we are really talking about, when we're talking about RESTful interface, it just happens to be that the most popular one is HTTP, right? So the RESTful interface refers to a representational state transfer. It is an architecture for clients and server web services. They are commonly leveraged as HTTP for the transport layer, and you can also use the SSL to secure data. The most important thing is that this is a stateless protocol, right? Not stateless protocol, but stateless framework, right? So unlike the typical TCP where it's connection oriented, right, or connection aware, right? When we connect to a client server, right, or a server, right, using a TCP client, for example, there is always a connection awareness. You're aware that whether the connection is broken or is it still connected and keep alive, right? So that's what we do. But for HTTP, it's a fire and forget situation, right? You send it out and that's it. There's no holding of anything, right? You send it out, and this is a really good architecture for the internet, right? Because imagine if everybody goes to the web server and requires us to hold a socket, how many web servers do you need to be able to service the masses, right? So really that's where the origin of RESTful came out, came from. Okay, the next protocol that we support, right, is the MQTT protocol, or what we call the message queue telemetry transport. What it does is that it's a pub/sub model. So basically, we need an intermediary broker that can be used as a medium to push out data. So what happens is that when you configure the IoT MQTT agent in Kepware, what we'll do is that we'll publish to the broker, and the broker can then publish to the respective other MQTT client that is reading this data. Right. So again, in a very typical Kepware scenario, you could put Kepware at the edge side, and then we can connect to it. And then before you send to the data to cloud, you could post-process it. Like using the advanced tech plugin that Nilesh showed earlier. So instead of sending the raw data across, you could actually pre-process or post-process it right within Kepware before we send it out to the cloud. Right. So these are some of the resources that we have for the IoT gateway, if you're keen. Okay, so before I go into the data logger, let me just break it and go straight for a demo. So if you look on the left side, right, what I have here is the IBM Watson platform. And what I'm going to do is that I'm actually going to create the agent. And over here, right, this is the part where you select the supported protocol. So right now we have the MQTT client and the REST server and REST client, right? So for this demo, I am going to send it to this platform. Let me see if I can clear the logs so that you won't see the data. Right. So over here, this is IBM's IBM Watson's their platform, right? It says, right, and if you run through the documentation, you can pretty much just throw the data and set up the object first. And then what you can do is that you can create the MQTT client, you push it to the URL of the cloud, and then you can select the respective topics. Right, then you enter your password, username and password, which you need to define on the Watson side, and fill out the client ID. So once I have one that's pre-created over here, right? So I'll just quickly show you. Right, so this is the URL that I'm sending to. This is the topic. It's going to be sent in a white format. And under the message, instead of using the standard template, I will be using the advanced template, which allows me to shape how my JSON payload looks like. And the reason why I want to do this is that I can, if you do it correctly, the cloud platform are able to ingest the data directly and make it easy to use in other services. You can also don't do this because it's optional. If you don't do this, what happens is that in the cloud platform, you need to do that whole extraction of data process, right? But you can actually do it in Kepware itself if you have the if you're familiar with the advanced template, right? Again, if you are keen, you go under the help file. There are many demos, or rather templates for you to take a look. So for example, if I key in this way, the data will look like this. And if I key into this way, right, it will look like this. Right. So again, it depends on how you play with the template. All right. So once we do that, basically I'll click OK to it. And then we can start adding the text. So for this case, I believe I will maybe just add a little bit of data. So I will add all this data in. So instead of a branch, I will select some of the parameters. All right. And you can see that now the data is actually being sent out. And on top of that, let's send some of the weather data into it. Again, I'll send it every 1 second. Right, so you can see that I have about 1, 2, 3, 4, 5, 6, about 8 tags being sent out. So if you go under the Watson platform, oh sorry, actually you need to look at the state over here. So you can see that actually we are able to connect to it and it's publishing now, so it's successful. Then we can go under the recent events, and you can see that a data has appeared. So with the advanced tag template, right, we're able to send it out in this particular format, right? So this is how the JSON representation looks like, right? So this is a JSON object, key value being D, and these are the other key values. So it's a JSON in the JSON, all right? Then if we go under the box, what we can do is that because the format is created correctly, you can quickly, do your visualization. Let's connect events. So we can create this. I guess this should be a number. Yeah. Then we can continue to add all the text in quickly. Feasibility value. Right, so this is the open weather parameter, if you can remember. In fact, I probably used the wrong tag for this. So let's just use the correct value instead. Oh, apparently it's true. Oh, there we go, 16 point something. So this is just a example of how one of the applications that you can do. All right. So pretty much just an example. So we can quickly connect to all the things that we created using the IoT gateway. We are able to send it out to the cloud platform and demonstrate the value into using a services within the platform itself. All right, so that's the IoT gateway. And then for the next section, it will be a pretty short one. I will talk about the data logger. All right, so if you recall back into the earlier diagrams, instead of just sending straight to the cloud, you may also want to have an offline copy of the data, right? So for that to happen, you can actually use data logger, which is another plugin that allows you to push the data into any ODBC compliant database. So things like your MySQL, SQL, Postgres, they're all ODBC compliant databases. So you can actually send it to them. All right. The driver itself also provides store and forward capabilities, which means that if in the events that Kepware is disconnected from the database, we are able to store it in a persistent file within your computer and then forward that back out once the connection goes back. All right. So again, as a reference back to the earlier diagram, we use the IoT gateway to send in real-time data. We can also use the data logger to log to a database locally. All right. Yeah. So this is an example of how the data looks like in the database, right? And these are some of the guides and a very nice video done by my colleague Carl, who did the video for you to take a look at the how to do it step by step. All right. So I'm going to do a quick demo. Again, it's going to be a straightforward demo. So over here, I have it's a MySQL database, and I'm using a PHP by admin to look at it. So you can see that inside these are some of the DB that I have, and over here I actually have a user called ATS. All right. So I'm going to use this user ATS to log data into a database here. Right. So similarly, I go into the data logger. Right. So data logger. And I go under to configure my DSN, right? So I click configure DSN. I go under the system DSN and I can click add. And once I do that, right, I will be able to go under and select my ODBC driver. So in this particular use case, I'm going to use the MySQL ODBC driver. So my database DSN name, I'm going to just call this XMATS, and then this will be a local server, a local DB, right? And the user is ATS. And then if I go under the database, I will select the demo, right? I'll click test, great, okay, and click OK. Okay, so I'm going to just choose it, click OK, so you can see that the proper DSN that we just created is in here. I'm going to key in the username and password again. And once I do that, the last thing that I need to do is to determine what table do I write in. So the table is inside the DB, and you can actually have all these tables. So the table is either you can log into an existing table, so any of this, or you can get Kepware to create the table for you. So I'm going to just do a quick table, right? Demo ATS, I'm going to just call it that. And I'm click OK. And what that does is that once you do this, go under the log item, you can create and choose the text that you want to send. So again, I'm going to just send the same text that I sent to the IBM Cloud I'm going to just continue with the text. So again, I have this bunch of text, right? So if you look at the events log, right, there's nothing going on now because I haven't enabled it. So the moment I enable it, you will be able to see the SQL command being run, right? So you can see that they created a table using create table, the database name, and this is the ID and parameters. And they created a table called demo ATS. So if I just go over to my admin and refresh it, I will actually be able to see the demo ATS. And then you can actually see the data itself. All right, so you can see in a very quick manner, if I know what I'm doing, I can actually get my data going everywhere pretty fast. I send it to the cloud, I log it to the database, and if you've got a Scada, they can come in straight away to take all the data that I have. And that really is why we consider ourselves a connectivity platform, because we are able to aggregate all the data and connections into a single software interface and send it out to various different data. All right, so that's pretty much the data logger. All right, so I will go into, because since we are talking about the data logger, I will talk about another similar driver, which is called the ODBC driver. Right, so the data logger allows you to push data into the database, but the ODBC driver allows you to pull the data from the database. All right, so again, the data logger lets you push the data to the database, but the ODBC lets you pull the data from the database. All right, so I'm going to just demonstrate it pretty quickly. So again, because we are pooling, right? So this is a connectivity layer, it's a driver. So what we're going to do is that I'll create a channel called ODBC client. ODBC, right? So the data source, right, will be the one that we created earlier on. This one. And then the username and password, I will be just keying it in. Click next, finish. And then now what we do is that we'll create a device that will pull a table out, right? So I'm going to just call this demo ATS. I want to match the table name, right? Oh, so for the model, usually it's generic. However, specifically for MySQL, there is a specific model for it. All right, just make sure you choose that because I'm using MySQL. And we just use the fixed table method to pull up the data. So on top of that, you can also run a SQL query, you can run a stored procedure, you can also have a dynamic table if you want to, right? But for simplicity and demo purposes, I will use the fixed table. I will choose the table. So in this case, the demo ATS, right? So when we finish this, what's going to happen is that the driver itself will pull the database and reach the demo ATS, and then programmatically retrieve the text inside here. Right, just give it some time, and you can see that it created 16,000 text. Right, so when I launch my quick client, I'm a bit hesitant because there's 16K text. Give me some moment. So you can see that on the bottom right corner, we are raising the text out. Ooh, I should probably stop the data logger. But it's okay, let's just let it run. So if you're connecting to another software and for some reason the only option they have is the database, you could use this ODBC driver to actually pull it, assuming the ODBC compliant database. Right. So if you look at the text created, this is actually similar to whatever we're seeing here. Right. So we want to see the value. See that? So it's actually pretty similar to this. Right, so you can see the same data here and there. All right, so in a very quick session, you can see that in fact this is pretty easy. Once you get your data in, you just need to configure your DSN. You throw in the log items, and you're pretty much done. At least from Kepware's perspective, right? Just bear in mind that because it's a database, right? you're supposed to do archiving, the database that you send to, there are other considerations in terms of performance. All right, so that's pretty much all I have for the IoT gateway and the data logger. I will do the last session, which is the link master and redundancy master now, right? So just bear with me. We are about to reach the end. Yeah, so the link master and redundancy. So if you recall what Nilesh has talked earlier on in the advanced plugin and some of the presentation, he briefly actually touched on the link master and the redundancy master. All right, so I'm going to do a little bit of a deep dive into the two products. Okay, so what is the link master? The link master is actually what we consider as a double-headed OPC DA client. Yeah, it's quite a long text, but basically what we do is that the software itself can connect to two OPC servers. All right, so if you're familiar with OPC, typically the client can connect to the server, but a server cannot connect to another server. So what we do is that we use the link master to connect to two OPC servers and pass the data around the two servers. And we achieve this by using what we call an input-output concept. All right. The link master, as additionally, is based off OPC DA. All right, OPC DA. It's not OPC UA. Okay, so it's DA only. So in a very nice graphical manner, what we can do is that because link master has two OPC clients, we connect to both OPC servers, and then we take in the data, and then we take one point as an input and send it out as the output. All right. So in a way, we can move data. Right. And I have a nice animation of doing it. Okay, so this is a screenshot of how it looks like. So if you can see, what we're doing is that I'm connecting to the a Kepware on a local machine, and I'm sending out to another tag in a local machine. So in this particular scenario, we are actually using Kepware as what we call a protocol translation. Because if you think about it, what you can do is that you can use the same OPC server. We can take a tag from the EM63, for example, and send it out to a tag in another driver, right? We could write it into a Modbus register. We could write it into the MT connect if you want to. Oh, sorry, the MT connect is read only. We could write it to say OPC UA and things like that, right? So essentially, the link master is able to operate as a protocol translator as well, right? And on another application of the link master, you can actually use it to aggregate all the different OPC servers, because the link master itself also comes with an OPC server, right? Or OPC DA server. So you can essentially use the link master to connect all the servers together and get a third-party OPC client and connect to it, right? In the event that you may need, if you want to do this, right, to aggregate it for simplicity of management. Right. So in terms of the translator, I think I talked about this earlier on, right? So I won't go too deep into it. So this is a screenshot of how it looks like. So you can see that we can actually pass the internal tag into a Modbus register. Right. So that's the end of the link master. So it's a very straightforward product. It is designed to take a data from a OPC server and send it to another tag in another OPC server, or even the same OPC server. All right, so input, output, input, output. That's it. So the next product that we have we're going to talk about is the redundancy master. So again, if you recall about what Nilesh said, it's actually a way to provide redundancy to some of the OPC software, right? So there are several types of redundancy. So the redundancy master is purpose-built for a specific kind of redundancy, right? So essentially what it does is that when you have OPC clients, right, and they want to set up to connect to multiple OPC servers, right, they need, in the event that the client itself doesn't have any redundant features built in, you can use the redundancy master to achieve this. All right. So in terms of the layers, what redundancy master is targeted for is on the client server layer, which is the yellow color diagram that you can see. All right. Then at the lower layer, when we talk about the device layer, right, that's what we call the connectivity layer or the media layer. And that's where we actually have a feature in Kepware's driver that allows you to achieve redundancy. And that feature is called MLR, media level redundancy. All right. So the redundancy master, for example, I think for this portion, we talk about the media level redundancy first. So that's the one that allows you to do redundant redundancy for different devices. All right. So you can actually have a pair of devices and act as a primary and secondary. Right. So this is targeted towards the lower layer, like I mentioned earlier on. Right. So if you want to set this up, just go under the driver, you double click the device itself, and then what will happen is that it will pop up. It will give you a pop-up that lets you define the secondary path. So the secondary path is a secondary device. Just bear in mind that your text should be in the same naming convention minimally. All right. And once you do that, you can see that in the diagram, right, the icon will change from one device into two devices. This means that this particular device or the text in here has been set to redundancy. Okay, then in terms of the media level redundancy, you can see that we offer quite a bit of different operating modes. So you can switch it on failure. For example, if the device goes into error, you can switch it on quality, on value, or no data change. For example, if you know that the particular data is supposed to change every 1 minute, and after 1 minute it's not changing, you can actually, even though the connection is healthy, there's probably something wrong with the device. So you can trigger the failover. All right. Then we talk about the redundancy master, which is designed for the higher level redundancy. All right. So this is the layer that we're talking about again, the higher level redundancy. Again, this is only required if your client or OPC DA client does not have redundancy built in. All right. If your client has redundancy built in, there is no need to have the redundancy master. All right. So this is an example, right? So in this particular use case, you can see that a DA client connects to the redundancy master, which then connects to a primary and secondary DA server. All right. So the data, right, is going this way. The PC is calling, and he decides that the primary is this guy. So it goes this way right now. Right. And then what happens is that if this thing fails, it will swing over, the redundancy master will swing over to the secondary, right? It will swing to the secondary. And during the swing, right, what you realize is that the DA client itself has no redundancy awareness. He just continues to talk to him, and this guy manages the swing over, right? So it's transparent to the DA client that is connected to the two OPC servers. And then when it recovers, it will swing it back to the correct primary. All right. Then in terms of connection modes, the redundancy master is able to do 3 different modes: the hot mode, warm mode, and cold mode. The key difference is in the how the connection is being created, right? So in the hot mode, on the OPC layer, we will connect to both OPC server and subscribe and pull with the data, right? So both servers are actively being pulled. In the next layer, we call it a warm mode. What it does is that all the items are added to the OPC server, but they are not pulled. They are set to inactive. So during the failover, right, the OPC client don't have to resubscribe and everything, and it goes straight to pull the item, which will trigger the driver. So it's a little bit slower than the hot mode, but it gives a more passive state to the secondary server. So the last one is called cold mode, where we have nothing to do to the secondary server at all. So there's nothing going on. There's only connection to the primary. All right. So when you fail over, it will be a little bit slower, because when you fail over, the redundancy master needs to start the subscription on the secondary server, and then create the tag list, and then starts to pull the data. So it's the lowest form of speed or connection mode. So in the redundancy master, you can also set, you can customize the monitoring capability. So instead of just doing a state, right? For example, error and no error, you can actually define like which tag to look at, and based on the tag condition, then you decide whether you want to fail over, right? So it's a more advanced form of failover conditions. There's also diagnostic built into the redundancy master, so you're able to see like what is the issue and when the failover happens with the timestamp and everything. And last but not least, to alert when you want to alert during a failover, there is a SMTP capability built in, so you can send an email to yourself and alert yourself that, okay, this primary has failed. Currently redundancy master is on secondary, things like that. All right. So that was primarily for our solution for OPC DA in terms of redundancy. And earlier on, we talked about the media level redundancy, which was designed for the connectivity layer, right? So on the other hand, if you want to provide media level redundancy, you want to provide redundancy to OPC UA, what you can do is that you can use the OPC UA client together with the MLR function to achieve redundancy using OPC UA. All right, so this may be a little bit confusing. Again, if you ever need this, just reach out to Sarla, and I think they will probably be able to advise you on how to do this. All right, so that's the end of my very quick presentation on redundancy solutions with Kepware. Right, so I hope that gives you some idea of how we do things. And I believe that was the last section.
Yeah, thank you so much, Steve. So our next session is a Q&A session, and we have a couple of questions related to our topics that we covered during this session. So I will ask Shinu to take over the Q&A session, and let's discuss some questions.
Yeah, thanks, Pooja. I think we have
just a moment.
Yeah. So I think we have a couple of questions, and if there are any other questions, please post it on the question session so that we can answer them. So Steve, there is a query question on IoT gateway.
Okay.
Yeah, there is a question asking, is there a possibility of store and forward functionality for MQTT client agent?
So what I didn't mention, unfortunately, was that there is a buffering capability into all the agents. So it's about 100K events per agent. But it's not exactly a store and forward, because for store and forward, what we do is that when we say store and forward, right, we take the data and we lock it to a persistent storage. So if your computer crashes and then it restarts, if the driver sees the file, they will continue to recover that. But the current implementation of the buffer, right, once if you it's an in-transit memory, so the moment the computer shuts down, all the data is gone. Currently, we have recognized this, and we have certain plans to enhance the IoT gateway later on. But I cannot tell when that will happen. But we have intention to bring that capability to all the protocols that are what we call northbound. That means to send it out of Kepware. So for protocols that we send out of Kepware, we have intention to have that capability eventually. Okay. So for today, the MQTT agent only has the 100K events per agent buffer.
Okay. So there was another one question with regard to data logger as well. Maximum number of tags we can store.
Maximum number of tags we can store using the data logger. Is that the question?
Yes, I think yeah.
Okay, so so the number of tags that you can store in the database, right, depends actually on the database. So it depends on what kind of database it is and the storage that you have. Because in each of the database where you create a table, right, there's a limitation of how many rows you can do. So depending on the database you use, they will have different numbers. So I cannot tell you exactly how many tags how many entries we can put into the database. You need to check the documentation of the database as well. So that's what I can tell you. But on our end, right, we don't have any hard-coded limitation in terms of on Kepware's portion. So you just need to be careful of the DB side.
Okay. Thanks, Steve. So Priyank, there's one question. You're there?
Yeah, I'm there.
Yeah. So can we add controller, emulator, or simulator as a device for testing purpose?
And we can use the simulator plugin, simulator driver for the simulation purpose. And all the controllers, all the channels and the devices, in the devices there is a option for simulation. Once you have, for example, if we have configured a Allen Bradley control logic Ethernet, okay, so in that device there is a in the properties of device there is an option of simulation, so you can enable that and you can use that as well.
Okay, it's asking for the driver name also.
So simulator driver is there, and instead of that, if you want to go with any other driver, you can use that.
Okay, thanks, Pring. And there's one more question, Priyanka, on for PLC driver, is there a automatic tag generation facility available?
Yeah, it is limited to few drivers. So, for example, Allen Bradley Bulletin 900, Allen Bradley Control Logic Ethernet, then after automation direct net, then after there are few, almost around 20 to 30 such drivers are there in which this facility is available.
Okay. So Pooja, I think these are a few questions which have come in, and others, if you have any queries or questions, you can just write to us or you can mail us.
Yes. Yes. So if you have any queries, you can directly mail us and we will revert to you as soon as possible. So yes. So here we conclude our session. It was great having you all and joining us for this webinar. So thank you so much. And thank you our speakers, Shinu, Steve, Priyank and Nilesh. Thank you for sharing your knowledge and sharing your expertise with our customers. It was great having you on our session today.
Thank you.
Thank you.
Yeah, thanks.
Thank you.